Welcome to my Ultimate AP Precalculus Practice Test Volume 2. This version of the test is designed to look just like the AP Precalculus Practice Test 2 found on AP Classroom. Now, it's not the same. I took the problems and I reworked them slightly to make them look different. So there's similarities for sure. They're not exactly the same, but there's just enough difference that I can be like, oh yeah, no, it's not the same problem, but it's pretty close. So let's get started. Consider the functions g and h given by g of x equals 3 to the x and h of x equals 9 to the x plus 1. In the xy plane, what is the x-coordinate of the point of intersection of the graphs of g and h? Well, let's just set these guys equal to each other because that's what it's asking. So I have 3 to the x equals 9 to the x plus 1. Should I get logs? Nah, I need a calculator for that. But you know what I could do? I could change that 9 into 3 squared. Yeah, so I have 3 squared to the x plus 1. And you know what? Let me throw parentheses there, and you'll see why in a second. That's going to equal 3 to the x. Now, there's a rule that says if you have a base to something equals the same base to something, set those somethings equal to each other. I'm not there yet. I have a power to another power. You multiply exponents when that happens. So I'm actually going to distribute 2 to the x plus 1. So 3 to the x equals 3 to the 2x plus 2. Now that I have 3 to the stuff equals 3 to the stuffs equal each other, like so. So I have x equals 2x plus 2. Let's subtract 2x from both sides. Okay, giving me negative x equals positive 2. And if negative x is positive 2, then positive x is negative 2 because multiply by negative 1. And so the answer is B. B for boy, oh boy, was this fun. Problem 1 down. Hope this helps. Problem 2 of Volume 2. The function h is given by h of x equals log base 3 of x. What input value in the domain of h yields an output value of negative 3? All right, so basically it's just saying log base 3 of what gives me negative 3? Well, let's write that in its exponential form. Okay, if you forget the exact formula for exponential form, I use log base b of y equals x, and you can turn that into b to the x equals y. So what that does with this guy, and I know this is x and that's y, don't overthink it. You're going to write out x equals 3 to the negative 3. Just have it written backwards. So let me see. 3 to the negative 3 is 1 over 3 to the third. And 3 to the third is 27. So x is going to equal 1 over 27, which is B. That's problem 2. I hope this helps. The function f is given by f of theta equals a negative 2 cosine theta. What are all the values of theta for theta is between 0, including 0, and 2 pi, but not including that, where f of theta equals negative 1. So basically, f of theta is this, f of theta is that, set them equal to each other. Negative 2 cos theta, I don't need the parentheses there, equals negative 1. Well, let's solve for theta. In order to do that, we have to get rid of negative 2 by doing the inverse operation, divide negative 2, divide negative 2. Cosine theta equals negative 1 over negative 2, positive 1 over 2. And if you're like, sir, Mr. Goat, sir, why did you leave all that space right there? Well, I have to get theta all by itself. And the only way to get theta all by itself is get rid of cosine by inverse cosine both sides. So inverse cosine both sides allows you to cross out the cosine, and now theta equals the inverse cosine of 1 over 2. Now, what does that mean? Well, if you're thinking unit circle thoughts, and that is a perfect circle, as you can clearly see, if you're thinking unit circle thoughts, cos theta is the x value. So what I want is the x value that gives me a half. So if you're thinking, all right, well, x's are positive on the right side, so it's positive over here, positive over here. If I were to think unit circle, the x would be root 3 over 2, root 2 over 2, root 1 over 2. So you give me 1/2 over there, and that's pi over 3. The one directly underneath it is going to give me my other positive 1 over 2, and that is 5 pi over 3. So theta is pi over 3, and 5 pi over 3. Those are my answers, which would be A. Amazing. A. Amazing. So I like to draw the unit circle because for me, I kind of need to have that visual there. It's not necessary if you have stuff memorized, but hey, I have both. So, because I'm a goat or whatever that means. Hope this helps. Which of the following expressions is equivalent to log base 4 of x over y to the 9th? Well, we know rules like this, that if you have like log base b of a plus log base b of b, that you combine those guys through multiplication. We also know that if we have log base b of big A minus log base b of big B, we combine those guys through division, so A over B. And we know that if we have something like n log base b of big A, we can bring that n up here and make that log base b of A to the n. Your teacher probably used different letters, but it's the same idea. This is working backwards. So we have to think of this as, okay, well, what must have happened to get the insides to be a division and an exponent? Well, we must have had subtraction, and we must have had a number in front of it. So what I'm going to do is I'm going to split the division part up first. I'm going to split these guys apart, saying in order to get something divided by something, we subtracted those somethings, the denominator part minus the numerator part. Now, that's not going to be good enough because I look at this and I see some stuff, but it looks like I have to get y all by itself in here. So in order to get y to the 9th, I must have had a coefficient of 9 in order to bring it up here. So I'm going to rewrite this as log base 4 of x minus, bring that 9 down, log base y. 9 log base y. And that's going to be D. Okay, so this is a question where you are being asked to expand, whereas more often than not, when you first learn logs, you're probably asked to condense them into a single logarithm. This is just working backwards. So it's the same rules, just opposite. Hope this helps. Which of the following statements is true about the exponential function h given by h of x, look at this mess, equals 12.512 times 0.717 to the x? All right, so it's talking about increasing, decreasing, concave up, concave down. Let's get a general graph of what this guy looks like. Now, this is in the form y equals a times b to the x. Now, if b is greater than 1, you have yourself exponential growth. And that's what we have. No, it's not what we have. We have a case where b is in between 0 and 1. That is a case of decay. Now, decay, normal decay, is graphed like this. Okay, your numbers get smaller and then it levels out at the x-axis. Now, if we have decay, what does A do? Well, if A is positive, it keeps it looking like that. If A is negative, what it does is it flips things, or better yet, reflects things over the x-axis. In this case, we have a case where A is positive, but B is in between 0 and 1. So we have regular looking decay, so it's going to look something like this. Now, what this looks like is it's decreasing, so not you, not you. And since it's the first half of concave up, it's going to be decreasing and concave up. So our answer for this guy is going to be C. All right, the answers change. Again, if A is negative, it flips it upside down, makes it look like that. That's not what I have. If B was positive, you'd have exponential growth, which looks like that. And if you were to flip that upside down, it would look like that. Okay, so if you need to rewind that and slow it down, Or as I think it was Usher, or maybe it was Ludacris who said, "Take that, rewind it back." Lil Jon got the beat to make the math questions go whack. Remember that song from like 2009? Yeah, with Usher and Ludacris and Lil Jon? The answer is C. Hope this helps. In the xy plane, the graph of a rational function has a hole at x equals -3. The function f also has a slant asymptote with a negative slope. Which of the following could define f of x? So let's take care of step 1 first. If there's a hole at x equals -3, that means this equation must have an x plus 3 and an x plus 3, one in the numerator, one in the denominator, same multiplicity on both. Okay, I'm not looking at, there's no multiplicity, there's no exponents here at all. So you have an x plus 3 in the numerator, you have an x plus 3 in the denominator, you're good so far. You have an x minus 3, x minus 3, x plus 3, but no x plus 3 up here, so B is out of the question. I'm just going to completely cross that out so I can not have to look at it. Negative x, x plus 3, x minus 6, x plus 3, x minus 9. So you have a possibility. X, x minus 3, x minus 1, x minus 3, x minus 1. So there's no x plus 3s here. You're also out of the question. So it's between A and C. So part 1 is we took care of the hole at x equals -3. Now what we have to do is try to figure out what the heck it means by having a negative slant asymptote. Well, a slant asymptote that's negative is going to look like this. Also, if it has a slant asymptote, the degree of the polynomial in the numerator has to be 1 more. Now, looking at both of these options, we have x, 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 and we have x, x, so that still works. And we have x, 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 and x, x, so that's still good. So it's not like that's going to eliminate anything. So let's try to kind of draw a picture of what this could possibly look like, knowing that it's not going to be accurate. So it might look something like this, right? And so what am I looking at for a picture like this that has a negative slant asymptote? Well, if I were to look at the end behavior, that might help me figure out which of these will match. The limit as x approaches -infinity of this guy that I just wrote out, as x approaches -infinity, it's going up. So it's going to approach positive infinity. When I figure out what the limit as x approaches positive infinity of f of x is, my fake problem, it looks like it's going down and to the right, which means it's approaching negative infinity. So what I need to do is take these guys and figure out which one of these has the end behavior where the negative infinity goes to positive infinity and vice versa on that one. So let's take A and test out A. Now, the way you find the end behavior of something that's all factored out is you take the leading coefficients of each factor and multiply them together. X times x times x is x to the third. Take the leading coefficients of all the factors in the denominator and do the same thing. I almost circled 5 there. Be careful. Don't circle 5. You take that and you simplify that and you get x. Now you take the limit as x approaches positive infinity and the limit as x approaches negative infinity of regular x. Now what that looks like is if you're looking at as x approaches positive infinity of x, you're kind of just like, and I'm doing air quotes that you can't see, plugging in infinity to x, which gives you infinity. And if I'm finding the limit as x approaches negative infinity of x, I'm, air quotes again, plugging in negative infinity for x, and that gives you negative infinity. So with A, the limit as x approaches infinity is infinity. That's the opposite of this. So that is a positive slant asymptote. I don't want A. A is not going to do it. Now let me do B and make sure that it works. Make sure I feel comfortable with it. I have negative x times x times x. So that'll give me, where do I have room? X, negative x cubed on top in the numerator, and x times x on the bottom, so x squared on the bottom. That simplifies out to negative x. So if I were to find the limit as x approaches positive infinity of negative x, I would plug infinity into x, and that gives me negative infinity. Okay. Similarly, if I were to take the limit as x approaches negative infinity of negative x, I would get negative negative infinity, which becomes positive infinity. And that's exactly what I want. So C is the answer. Okay, so kind of a difficult problem, kind of a challenging problem, but yeah, we used end behavior to figure it out, and it was kind of fun. I had a lot of fun. I hope you did too. Hope this helps. Oh, look at this problem. You have no clue how long it took me to make this problem. Just for you kids, just to get 30 views and like 3 cents. At time t equals 0, water begins pouring into an empty container at a constant rate. The water pours into the container until it's full. The situation is modeled by the given graph where time in seconds is the independent variable, as you can see here, and the depth of the water in the container in centimeters is the dependent variable here, height of the water. For which of the following containers would the graph be appropriate? So let's see what's going on. Okay, it starts filling up kind of quickly, and then slows down and then picks up the pace again. So if you were to pour this in, okay, this would start filling in faster, 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 and then slow, slow, slow. So A is kind of the opposite of we want. Now, if you're like, well, what do you mean it fills in faster? Since the width gets skinnier, it fills at a faster rate. This says start out slow and then go slower and then go fast again. Okay, so start out, maybe I should have written it out this way. Start out kind of fast, and then go slower and then fast again because it goes from a steep slope to a shallow slope to the same steepness. Okay. B looks promising. It starts out kind of normal, but since it's a wider shape, the rate or the speed at which this fills up starts to slow down. So it goes slower, 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 and then all of a sudden it picks up the speed again because the width of my shape gets skinny again. So it starts normal, gets slower, and then starts picking up the speed. So B seems to do the trick. Now, what C would look like is it's going to fill up at a constant rate. So the graph of that's going to look like this. This is an elephant. I have no clue what the heck that's going to look like, but it certainly isn't going to be a pretty little curve that took me forever to make on Desmos for you kids. So the answer for this one is B, because again, you look at the slopes, it goes kind of fast and then slows down and then slows down and then picks up the speed again. And in order for that to happen, you must have a skinny to wide to skinny again. B is going to be our guy, baby. B for bowl. Well, it's not really, well, it's kind of a bowl, but it's a sphere. Hope this helps. A new car, initially priced at $29,000 and $999, depreciates in value by 15% each year. Depreciates, that means loses its value. And in this case, it loses its value by 8%. Which of the following models a function for the value of the car v of t as a function of time in years? Now, if something's going to lose its value by 8%, what's happening is going to be exponential decay in this case. Now, what this means is you're not going to lose like $3,000 every year. It's not going to go from like $30,000 to $27,000. I'm just pretending it's 10% just to make the numbers easy, to 25. No, it's not going to do that every year. This is not linear. This is exponential. So that gets rid of both of you. These are linear because it's something times t plus or minus something, blah, blah, blah. Okay, it's going to look like this. Now, if you're tempted to say, okay, well, what we'll do is we'll just multiply it by 0.15 because 15% is 0.15. No. If something loses its value by 15%, what you're doing is you're taking 100%, subtracting 15%, and you're now taking 85% of that price. So what we're going to do is we're going to take our initial value, which is that. We're going to multiply it by 80%, which is 0.85, and we're going to repeat the process every t years. So that after 2 years, we do 29,999 times 0.85, whatever that number is, times 0.85 again. You're going to take 85% of the new price after every single year. So that what's going to happen is it might lose like 4,500, I think, is going to be the value the first year, give or take a couple pennies. But then it's going to lose like maybe 4,200 and then maybe like 3,000 something. And it's going to lose its value, but slow down in how much value it loses. It'll never hit zero. It'll still have worth. It'll lose value initially, immediately, right away, but it's going to start losing its value at a slower pace. So the guy that we get is C. D means you're going to take away 85%. That's definitely not what we want to do. Don't buy a car like that. Don't buy a car like that. And speaking of car, the answer is C. And car, last time I checked, starts with C. Hope this helps. Which of the following is not equivalent to cos squared x over 1 minus cos squared x? So we want the lie. So 3 of these are correct. 1 of these is not. Whenever you see a cos squared or a sine squared or a tan squared or anything squared, you want to think those Pythagorean identities. If I have cos squared x, I am thinking the Pythagorean identity that says sine squared x rather, plus cos squared x equals 1. I really don't have that here, but ooh, you know what I do have? If I subtract cos squared x from both sides, sine squared x is the same as 1 minus cos squared pretty looking x. So what I can do is replace that 1 minus cos squared x with sine squared x. I have cos squared x over sine squared x. Okay. So any of these match? No. Oh, but you know what? Cos squared x over sine squared x is cos squared, or cos x over sine x is cotangent. So cos squared x over sine squared x is cotangent squared x. So you are true. So I like you. I'm going to keep you. Ooh, cos squared x is the same as cos x times cos x, and sine squared x is the same as sine x sine x. So you are a true statement. And let me see. Oh, if I were to move cosine squared x down, I would have secant squared x on the bottom. And if I were to move sine squared x up, I would have cosine squared or cosecant squared x on the top, which makes you work. Oh, tangent. You little rascal, it's not tan squared x. And the moment I got the fact that it was cotangent squared x as the answer, that automatically gets me to the point where I can say it definitely can't be B. So B is going to be my answer. Remember, I want the one that is not equal to that. And B is the one that's not equal. Wasn't that neat? Hope this helps. The location of point X in polar coordinates r theta is -3 pi over 6. What is the location of point X in rectangular coordinates xy? You know very well that rectangular coordinates, if viewed from a trigonometric point of view, is going to be r cos theta, r sine theta. Well, you're my r, and you're my theta. So let's do some simplifying, shall we? You're going to be -3 cosine pi over 6, and you're going to be -3 sine pi over 6. -3 times cosine pi over 6 is going to be -3 times the x value that you have if you go to pi over 6 on the unit circle. So if you need to draw the unit circle and say, all right, pi over 6, that's the first one. So the x value of that first one is going to be √3 over 2. So it's going to be √3 over 2. Similarly, the sine value of pi over 6 is going to be the y value, which is going to be 1/2 for that first guy right there. So -3 times 1/2. -3 times √3 over 2 is going to be -3 √3 over 2. You know what? Let me write it out the way that they want me to write it out just to be a little more consistent. -3 in the numerator, √3 over 2. You're going to be -3 over 2. B is going to be my guy. All right, so again, if you have this memorized, drawing that out's not necessary, but this is me converting polar into rectangular by going back to the old trig version of what it means to be rectangular. And so there you have it. Hope this helps. Problemo once a function and two coordinates are displayed on the graph. There's my function, there's my coordinates. That looks exponential to me. What is the y value of the function when the x value is -1? Well, this is exponential for sure. And so what I'm going to do is I'm going to create an xy table by drawing that perfectly straight line and just kind of go backwards. So I have 3/8 and I have 4/16. So close to John 3:16, my favorite Bible verse. It looks like going this way, you multiply by 2. So going backwards, you divide by 2. Makes sense. So you would be 2, 4, because 8 divided by 2 is 4. 1, 2, because 4 divided by 2 is 2. 0, 1, because of divided by 2. And here we are at -1. 1 divided by 2 is +1/2. So pretty simple problem. You just need to recognize that it's exponential. And with exponentials, you multiply this number by the same number every time. So working backwards is the inverse of multiplication. Division. Hope this helps. The table gives values for a function g at selected values of x. Which of the following statements is true? So it looks like it wants us to talk about linear, quadratic, linear, quadratic. So this is what I have to do. I have to make sure that the x values go up by the same number every time, and they go up by 2. Now, usually when they see these, they go up by 1. But in this case, with this problem, I had them go up by 2 because just like 2 chains, I'm different. Now, what we're looking for over here is to see the first order of rates of change. That gives us whether or not this is linear. If the rate of change is constant throughout, it's a linear function. So what do we do to get from 8 to 9 to 8 to 5 to 0? Well, I'll tell you one thing. It ain't linear. We add 1, we subtract 1. We subtract 3, we subtract 5. It's not linear. So it's not linear, which means no to U and no to U, A and C are not an option. Now, to test to see if it's quadratic, we need to see if the rate of change is constant. So what happens here? Well, from 1 to -1, you subtract 2. And from -1 to -3, you subtract 2. And from -3 to -5, you subtract 2. So this is quadratic. This is quadratic. And it's quadratic because the second differences of the output values over equal interval input values are constant. Now, it's D, but if you're looking at two phrases that you don't like, here's phrase number 1. Equal interval input values. That is these guys. Since these guys change the same exact amount of numbers, or it's added to every single time, that is the definition of equal interval input values. Okay? And that's constant. Thing number 2 that we care about is the successive second differences of the output values. Some problems might word it as the rates of change of the rate of change or the second rate of change. Either way, it's going to be this guy because it's the second differences and not the first. The first differences would make it linear. So the answer is D, and hopefully I explained these well enough with minor stuttering. For, again, equal length, I can never say this correct. Equal input value lengths is very difficult to say. Say it twice, 5 times. I dare you. I'll give you a second. See, I told you couldn't do it. Hope this helps. The function f is given by f of n equals -2 log base 3 of n. And the function g is given by g of n equals 3 to the nth. If the function h is given by f of g of n, which of the following expressions for h of n, which of the following is an expression for h of n for n of 0? So I prefer, n is greater than 0, I prefer to write this out as f of g of n. Okay, that's how I like to do it. And if you're like, no, I prefer the fog looking thing, well then good for you. What you do with this is you start out with f, and f is -2 log base 3 of n. You write out all of f and leave a nice big blank space for where n is, like so. You replace that n with whatever g of n is, and g of n is 3 to the nth power. Now, there's two ways that you can look at this. And I'm going to do both because why not? Way number one, and let me rewrite it out. Way number one that you can look at this is you could say, oh, wait a minute. Log base 3 of 3 to the n allows the log base 3 and the 3 to cancel each other out and drops the n down, so we have -2n. That's one way of looking at it, check. Another way of looking at it is you could say, I can bring that -2 up here, and so I have log base 3 of 3 to the n to the second power, negative second power. Multiply these two, and that gives you log base 3 of 3 to the -2n. Just like we had over here, log base 3 of 3 cancels out, and you're left with -2n. Either way, you get -2n. Which method is easier? I don't know. But we did it in two different ways, and that's very important in math land, pre-calculus math land. They want you to look at things in like 4 different ways, and I did 2 of them. So there you have it. Hope this helps. This is the binomial theorem. The binomial theorem is trash. But what we are being asked to do is find the coefficient of the third term when b of x is expanded and written in standard form. So I have to do the binomial theorem. So let me do the whole thing, even though it's a pain in the butt. First, you need Pascal's triangle. Okay, Pascal's triangle starts with the number 1 over here, and the number 1 exists when you have a degree of 0. Okay, then you go to 1, 1. That's a degree of 1. Then you go 1, 2, 1, and the pattern here is any number that is underneath and in between is the sum of the numbers above. That's degree 2. We are going to work our way to degree 4. Okay, so we have 1, 3, 3, 1. That's degree 3. And last but not least, degree 4 is going to be 1, 4, 6, 4, 1. All right, I'll explain what those guys are in a second. Now, what you do when you do Pascal's triangle and the binomial theorem is you take this guy and pretend it's A and B. So you have A plus B to the nth. What you do with a plus b to the nth, and in this case n is 4, is you write out these numbers, and I'm going to spread them out. 4, 1, not 4, oh my gosh, just 1, silly me. I looked at the degree 4 and got it roped in. 1, 4, 6, 4, 1. You start out with the first coefficient, the first term, and you say a to the 4th and work your way down. A to the 3rd, a to the 2nd, a to the 1st, no more a. Then you take b, do b to the 4th all the way to the right, and you work your way down from the right, like so. That's 1. When I said like so, it threw me off. No b. Plus sign, plus sign, plus sign, plus sign. Now, all I have to do here is find out the third term. This is already written in standard form, and it's going to be the coefficient of the third term, not even the whole thing, but I am going to do the whole thing just for practice. We called A x, so A is x, and we called B -4, so now I have to plug those in. So I have 1 times x to the 4th plus 4 times x to the 3rd times -4 plus 6 times x squared, -4 squared, plus 4 times x to the 1st, -4 to the 3rd, plus 1 times -4 to the 4th. Last but not least, let's simplify this guy out. X to the 4th, 4 times -4 is -16, x to the 3rd. 6 times -4 squared. -4 squared is 16, and 6 times 16 is 96. So positive 96, which gives us our answer. X squared. Negative 4 times negative 4 times negative 4 is negative 64. And 4 times negative 64 is negative 256. Drop down the X. And then again, negative 4 times negative 4 times negative 4 times negative 4 is the positive 256. So that's binomial. You go one more degree and then you add more numbers. You go one more degree and then you add more numbers. It's not a pleasant process at all, and you're not going to see it that much, unfortunately, on these AP exams. So maybe you'll see it, maybe you won't. But if you do, that's how you do it. So hope it helps. Which sinusoidal function is represented in the graph below? All right, so I'm going to write out, I have sines and cosines. I'm going to write out the basic version where you have y equals a. I'll write out trig, and trig could represent sine or cosine here because that's clearly what they want. Parentheses b to the x minus c, parentheses, parentheses, plus d. The first thing that you should always start out with when trying to figure out an equation is your midline. At least that's one of the first things you should figure out. Okay, where do I have a horizontal line cutting this guy in half? Well, it looks like that happens at -1. So this is going to be -1, which eliminates C. The first thing you can do now that you have your midline is find your amplitude pretty easy, and that's by going from your midline to the maximum value and seeing what the distance of that is. So 1 minus -1 gives me a distance of 2. My amplitude is 2. Now, before I cross A and B out, here's the thing. In any of these or in both of these situations, I have no horizontal translation. This guy represents a shift to the left or to the right. I don't have that in any of my options, so I'm not going to worry about C. So basically what's happening here is I'm starting right there and working my way down. Now sine, regular sine, when graphed, looks like this. This guy is the flipped version of it where it looks like that. So if this is regular sine, then this is going to be negative sine. So the answer's got to be A. Now let me make sure that I'm good. Let me make sure that I'm good and make sure that the frequency is pi. Now B stands for the frequency. Now what the frequency gets you is if you have the frequency of pi, the period is going to be 2 pi over the frequency. So in this case, my period is 2. So if I were to look at, I don't know, an obvious spot like here and go 2 spaces later, it looks like the period is 2. So everything seems to match quite nicely. Again, negative sine, period of 2, which makes a frequency of pi. It goes down 1, giving the midline of -1. So yeah, the answer is going to be A. Hope this helps. The graph below models a sinusoidal function with points A, B, C, and D representing coordinates on the curve. One of A, B, C, or D represents an inflection point, probably U, because it's right in the middle. And one also represents a relative maximum, probably U, because, Rat Monster from, what's it called? What are they 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 called? They sing Butter. They sing BTS. Anyway, relative maximum. Which of the 4 locations would represent the largest instantaneous rate of change? What the heck does instantaneous rate of change mean? That means slope at a point. So the best way to describe this is make believe that you're riding on a roller coaster, and at which one of these points are you going to be the steepest? Okay, the steepest positive instantaneous rate of change. Well, if this was a roller coaster, right now you're going down, and you're leveling off. So maybe right here your slope would be almost 0 or 0. Now we're moving our way back, and now we're pretty steep. That looks like it's kind of pretty steep, but this is even steeper, because it's the inflection point. and the inflection point is going to have the steepest. How do I know that? Well, concave up, okay, means it has, like right here, in this case, it's decreasing, but this is increasing at an increasing rate, which means the rate, also known as slope, is increasing up until this very moment right here where it hits its peak increase. Now it starts decreasing. So what's going to happen is if we are riding a roller coaster, we are at its maximum slope here, and then it starts leveling out and has a zero here. So the maximum slope is going to happen at an inflection point. Okay, so the answer in this case is going to be B. Now, if we were going to be asked the least, the least is going to be where it's decreasing and closest to a maximum or a minimum. But that's not what we're asked here. We're asking for the steepness, and the steepness is the steepest at an inflection point. Kind of tricky problem, but I hope I explained it well enough with the whole roller coaster thing, and I hope this helps. 4 polar coordinates are given by C, A, T, and S. It's an interesting choice of letters. Who made that problem? Which statement is false? All right, so 4 coordinates, some positive, some negatives. Let's understand what that means. A polar coordinate is given to you by a R, which pretty much stands for radius, and an angle, which is your direction counterclockwise from the positive x-axis. So if you were to ask something like C, and we'll go over it slowly just in case you're not used to these problems, you view this from a viewpoint of a unit circle. Now, all of the radii, all of these guys are some form of 2. So I'm going to draw a terrible circle, as you can see. But the radius for all of this, the radius of this whole circle is going to be 2. So we're going to pretend that that point right there is 2, 0. Now, if I were to graph 2, what I do is I make sure that I know that the length of my line that I draw, or the point rather, is going to be 2 units away from the center, also called the pole. Now, this guy gives me a direction going in the counterclockwise motion from the positive x-axis. So you're basically going this way starting here. So you're 0, like a normal unit circle, pi over 2, pi 3 pi over 2. So without being perfect, if I'm going to go in the direction of pi over 3 and put a dot 2 units away from the pole, I'm literally going to have a point right around here. I'll call you C. Okay, so that's where C is going to be. Now, if I were looking at these, and let me clear some of this mess up. If I were looking at these and thinking negative radius, what does that mean? Negative R. Well, let's figure out what pi over 6 is first. Pi over 6 is like way down here. So I'm going to go all the way counterclockwise to way down here. So I'm going counterclockwise way over here. Okay, but since this is negative 2, I'm not going to put a dot here. I'm going to go in the opposite direction. So my dot has me going all the way around here, but since it's going to be a negative 2, I'm going to put my dot right there. Okay, so you're going to be A. Again, normally you would go in this direction, but since it's negative 2, you go in the opposite direction, which gives me that A right there. I'll leave those arrows just in case I need them. Now, the same thing's going to happen again and again. Okay, we go to negative pi over 4. Now, negative pi over 4 has me going clockwise. So regular pi over 4 would be halfway to pi over 2. So negative pi over 4 would be negative halfway to negative pi over 2, or basically right here. So you're now here, but again, we have a negative distance. So instead of putting my dot on 2 over here, I'm going to put my dot right here in the negative distance. So T is kind of next to A. S, I'm sure by now you're kind of getting the point. If you see a little thing pop up, that's me getting a different color. We're going with orange. pi or 3 pi over 4 is right around here, but it's negative. So 3 pi over 4 lives here, but a negative distance puts me over there. That's my s. So let's see what they're asking and circle the one that's the lie. Point C exists in quadrant 1. That's true because 2 represents a positive distance. That's true from the pole at the angle pi over 3 when rotated counterclockwise from the positive x-axis here. Don't see anything wrong with that. So A is not going to be the option we want because it's actually a true statement. Point A exists in quadrant 2. So far, so good, because negative 2 represents a distance in the opposite direction from the pole at angle 11 pi over 6 when rotated counterclockwise from the positive x-axis. Again, no lies detected. B is not going to be our answer. B is a true statement. The point T exists in quadrant 4 because negative 2, T is in quadrant 2. So we have our lie already. So that's the guy we want. But let's keep going because negative 2 represents a distance in the opposite direction from the pole at angle negative pi over 4 when rotated counterclockwise. So there's error number 1. There's error number 2. So that's why C is wrong. Because if you're going in the negative direction, you're rotating it clockwise. Either way, we could have stopped right here. S is in quadrant 4 because negative 2 represents a negative distance from the pole at the angle 3 pi over counterclockwise. So a true statement. C is definitely the lie. So C is the one that we're going to circle. So I did a lot here, but that's okay. I just wanted to explain things thoroughly because, you know, this is towards the end of Unit 3 and you never know how much polar coordinate stuff you're given. Plus, there's always, when it's written out this much, you really need to be thorough, and I just wanted to be thorough. So I hope this helps. Michael and Dwight were working on a problem where they were asked to write a sinusoidal equation representing the height of a Ferris wheel with a radius of 21 meters, rotating at a rate of 1 revolution per 100 seconds. What do we have? We have a circular object with radius of 21. So whenever you're dealing with sinusoidal stuff, right, and you're given a circle and you're given a radius, automatically that's probably going to be your amplitude. And that is going to be our amplitude. I'm just giving you a heads up. What else do we know? Well, if it rotates once every 100 seconds, then that's going to be our period. Okay, let's keep on going. It was assumed that the ride begins when the rider of the Ferris wheel is at the bottom of the ride. So Dwight wrote out the equation h of t equals negative 21 cosine pi over 50 t plus 21. Now let's see what that looks like. Okay, let's see the picture that Dwight came up with. Let's see if there's any issues or whatever. All right, so midline 21. Okay. Negative 21 cosine gives us that amplitude of 21. So we're up here at 42. We're down here at 0. Negative cosine is actually right here. And if you're like, well, why not sine or something like that? Well, let's think it out. Cosine looks like this, right? But we're starting at the bottom, like Drake, which starts down here and looks like that. Now, if we shift that up a bunch, if we shift that up the amplitude, we are now starting out down here, and the height's going to go up, and it's going to come down and repeat itself at 100. So the picture, I mean, given what we have, Dwight looks like he did a pretty decent job. All right, now pi over 50, if you're wondering, well, where did that come from? This is a cosine function, so that's our frequency. And the way you get frequency is you do 2 pi over the period, which is 100, and that simplifies out to pi over 50, like so. Okay, so everything seems fine. Everything seems good. Oh, but Michael swoops in and reminds Dwight that the bottom of the ride actually is 2 meters off the ground. So 2 meters off the ground is going to be up 1, 2, making the midline 23, the bottom 2, and the bottom 44. Now, how does that change this function? Just the midline. That's it. So all we have to do is just change that to 23. Which, should I give the same answer twice? I did. Ugh. So I think I meant to put 22 here, but I made it 23. I was thinking Taylor Swift thoughts, but I accidentally made them both 23. So, you get the idea, even though it's a poorly written problem, you get the idea. But yeah, that's your guy, Michael and Dwight. That's what she said, right? It's the show, The Office. Hope this helps. In the XY plane, two different angles, alpha, ooh, are we making a problem about me? And beta are in standard position and share a terminal ray. What does that mean? Well, if you were to graph something, okay, here's your regular thing, your regular initial ray, and then your terminal ray is going to show up like this. Both of these guys will look like this, have the same exact picture. So, whatever this is, if I have another one, it's because you added 2 pi or subtracted 2 pi or added 4 pi or whatever. Okay, you spun around again and got the same exact thing. Or maybe you spun around in the opposite direction, which is what minus 2 pi would be. So, based on this information, which the following gives possible values for alpha and beta. So they're going to give you two equations. And are these, not two equations, but two radians? And you have to figure out, are these guys the same ones? Well, this is negative 3/4 pi, which lives over here. Is me adding 2 pi going to get me 3 pi over 4? No, then A is not the option. Is me adding 2 pi going to give me that? Well, we're actually subtracting, so is me subtracting 2 pi going to give me negative pi over 4? Nope, negative pi over 4 is if you subtract 3/4 pi by regular pi. So that's just spinning it in the opposite direction like that. So that's no good. Pi and 2 pi, no, here's pi, here's 2 pi, they're definitely not the same ones. So it's got to be u. So if I'm going from a positive to a negative, it must be because I took 11 pi over 6, subtracted 2 pi, which looks sloppy, so I'll turn 2 pi into 12 pi over 6 to get negative 1 pi over 6, or just negative pi over 6. So yeah, 19 is a problem. That's basically saying, hey, which of these guys are exactly the same? Add 2 pi, subtract 2 pi, blah, 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 blah. D is going to be your answer. Okay, pretty standard. Hope this helps. In the xy plane, the function h is given by h of x equals 4 to the x plus 9, and it's a horizontal translation of the exponential function f. Well, we could see that because we have positive 9 trapped inside the x parentheses, which means we actually make our guy move it left, a negative horizontal translation. So there it is. So yeah, there's the regular function. By adding 9 inside the parentheses, we move left 9. Cool. Which of the following is equivalent for h of x? That expresses h as a vertical dilation. All right, so a vertical dilation is not the same as a translation. So if you're thinking, oh, they want us to add or subtract. No. That's translation. When you do a vertical dilation, you take your f of x and you just multiply some number to it. Okay, so if our f of x is 4 of x, you're just going to take a number, and it looks like they want us to use 2 here, and multiply 2 to it. So b is going to be our guy. Now, that's a vertical dilation. If you're thinking, well, what about a horizontal dilation? The horizontal dilation would look like this. So now you'd be taking 4 to the 2x, okay, which is an option that I probably should have given, but I gave you A, which is kind of close. But yeah, that's what we have here. This represents a vertical dilation, not to be confused with a horizontal dilation, not to be confused with a vertical translation, which is when you would add 2 to 4 of x, 4 to the x. So yeah, transformation stuff is kind of a mess. But yeah, we did it, and boy, did I have fun. Hope this helps. The table shows a portion of function h of x that is either concave up or concave down, but not both. Describe the graph of the function on the interval 1 to 5. So here we go. We have our graph between 1 to 5. And it's telling us right now that it's going to be concave up or concave down. So what I'm going to do is I'm going to find the rate of change, which gives us our linear change. And so this is going to help us figure out what the average rate of change is going to be. So linear is also like when you're finding the linear stuff here, you're finding the regular rate of change. So what are we doing here? Well, we are going from -3 to -10. By the way, these all go up by 1. So that makes it the equal length input value intervals being the same. Okay. These go up by, what am I doing? Adding 3. you're adding 5, you're adding 7, and you're adding 9. So what we have is these go up by the same amount of numbers. These go up by different numbers, but the numbers as you go up are increasing. So we would say that the rate of change is increasing, making it concave up. Okay, so the graph of h is concave down? Nope. The graph of h is concave up because the function is increasing and the average rate of change over equal length input value intervals is increasing. Yup. The graph of h is concave down? Nope. The graph of h is concave up because the function is increasing and the average rate of change over equal length input value intervals is decreasing. Nope. So whenever your rate of change is increasing, you're looking at concave up. Okay, simple as that. Boy, was that fun. Hope this helps. Which equation below represents P of t equals 3 sine 2t minus 4 translated 4 or pi over 4 units left? All right, well, I'm going to compare this to like the regular old sinusoidal thing. So we have sine, we have parentheses b. In this case, it's t, so t minus e, close it, minus 4. Well, what do we have? We have a is 3, so we have 3 already. We have sine. What I'm going to do is I'm going to separate the t and the 2 with that parentheses. So we're basically pulling this out. Now that gives us frequency. Okay. We don't know what c is, although we do, but we don't know what c is. But what this does is when it's worded out like this, okay, when you are going to translate horizontally, you have to include these parentheses here if you have a coefficient in front of your variable. We do. We can't just say something like 2t blah, 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 blah something because you're not doing it right. You need those parentheses there. So if I'm translating left, that means c is negative pi over 4. So if c is negative pi over 4, we have a negative pi over 4, giving us 3 sine parentheses 2t plus pi over 4, close it, minus 4. And c is the one that gives us that parentheses, the doubled up parentheses, and the positive. So again, things kind of seem backwards when you're inside this parentheses with your variable. And why would that change here? So make sure you write it all out. Make sure you include the parentheses. Make sure you do opposite of what it seems like it should be whenever you're dealing with horizontal translations. And you'll just get it right, baby. Hope this helps. You ready for a stupid problem? The function p models the population of a city in thousands of people as a function of time t. In years, t's got to be positive because, real life. The function r models water consumption in gallons per day as a function of population size. Let w be the composition function defined by w of t equals r of p of t. Which of the following statements is true about w? Now, before I go on further, this is a problem that looks very similar to an actual AP Precalculus, legit AP test, AP Precalc, AP test problem, practice problem test. Okay, so it looks very similar. And when you're finding w of t, it's still a function of time. So that's it. I mean, it's a strange problem. Like, you're not given anything to simplify. You're not given any math to do. You're just saying, okay, well, it's still a function of time because it's w of t. So, yeah, I mean, that's it. That's this problem. Pretty stupid, but, hope this helps. The arc length of arc QP of the circle below is 11. By the way, arc length is given by the formula arc length equals radius times central angle. The circle has a radius of 8. Which of the following would give the y value of point P? All right, well, it tells us that the arc length, which is given to us by doing radius times the central angle, is going to be 11. So arc length is 11. that's going to equal a radius of 8 times the central of angle of theta, which we don't know. So theta is 11 over 8. Okay, theta is 11 over 8. Well, that's nice. We have the theta part. Now, what we have to do is we have to give the y value of point P. Since we have a radius of 8, we are not just doing, regular cos theta, regular sine theta. This is not the unit circle. This has a radius of 8, so we have to throw the r there. Now, the y value is going to be sine. So we need to find r sine theta. R is 8. Sine is sine. Theta is 11 over 8. Our answer is C. Okay, so kind of a different problem, kind of a unique problem. You have to remember what the arc length is, which not everybody does, but there you have it. It's a radius times central angle, and then the rest is up to you. Power is yours. Captain Planet. Hope this helps. Which of the following equations represents all vertical asymptotes of f of x equals 6 secant x minus pi over 2? Vertical asymptotes exists when the denominator of a fraction equals 0. So it would make sense to me that maybe I should take secant and change it. So I could draw this out or write this out as f of x equals 6 times 1 over cosine, because secant is 1 over cosine, x minus pi over 2. Again, what gets me vertical asymptotes? Whenever the denominator is undefined. So I want to find out when cos x minus pi over 2 equals 0. 6 has no effect. 6 just gives me height. It doesn't tell me anything about the vertical asymptotes. So if I have cosine of x minus pi over 2 equals 0, and I want to get x all by itself. Since I have cosine of stuff, right away I can inverse cosine both sides. So I'm going to inverse cosine both sides, bada bing, and that leaves me with x minus pi over 2 equals whatever the inverse cosine of 0 is. So cosine is x, so what degrees give me an x value of 0? 2 of them, pi over 2 and 3 pi over 2. So I'm going to solve these for two different equations. I have x minus pi over 2 equals my one option, pi over 2. And I have x minus pi over 2 equals my other option, 3 pi over 2. Add pi over 2, add pi over 2, and a half a pi plus a half a pi gives me a whole pi. Sounds delicious. That's one option. My other option is to do the same exact process, add pi over 2, and 3 pi over 2 plus pi over 2 is going to be 4 pi over 2, which is 2 pi. Now here, it's asking me to find all of them. So technically I have pi plus 2k, where k is any integer, and 2 pi plus 2k, which k is any integer, because you always add 2 k's to it. And if you're wondering, I'm sorry, 2 pi k, oh boy, would that change everything. Now, what that means is I have options like pi, and 2 pi, and 3 pi, and 4 pi, and so on, so on, so on. So basically, how can I write that out? Well, if I wanted to, I could take 2 pi, and just keep adding a pi, add a pi, add a pi, add a pi, add a pi. Now, if you're like, well, what about pi? Well, k is any integer, which means it could be -1, -2, -3. So all of these will work. So A is going to be my guy because all of these are only focused on adding 2 pi instead of regular pi. So, we had to word the answer differently than maybe what we're used to. But the numbers are convenient enough where we can make A our selection. Hope this helps. Which of the following statements about f of x equals x squared minus 9 in the numerator, x minus 3 in parentheses squared times x plus 5 in the denominator is false? They want the lie. So it's like 3 truths and a lie, the game that you played in high school. I didn't because I didn't have friends. This is what we're looking at. We're looking at a rational function. The bottom is factor, the denominator is factor, the top is not. So let's factor out the numerator. X squared minus 9 is a difference of squares. X squared minus 3 squared. So you become x plus 3, x minus 3, like so. The denominator does not change. X minus 3 in parentheses squared, x plus 5. Okay. Now, again, we're looking at, just briefly zooming through this, we're looking at magic words like vertical asymptotes and zeros and holes. So what we need to do is we need to pretend that each of these factors are set equal to 0 and figure out their magic numbers. For example, if x plus 3 was equal to 0, you subtract 3 and negative 3 is your magic number. Positive 3 is your magic number. Positive 3 is your magic number. Negative 5 is your magic number. Now, when we're dealing with rational functions, we're dealing with vertical asymptotes, holes, and zeros. Up here in the numerator, we have x plus 3 in parentheses and nothing else like it. If you have a factor that doesn't repeat itself in the numerator, you have yourself a 0, and that's what negative 3 is going to be. And what we also have in the numerator is x minus 3. In the denominator, we have 2 of those. So if the multiplicity of a factor in the denominator is greater than the numerator, the denominator is more powerful and you have yourself a vertical asymptote. If they were exactly the same, you'd have a hole. If they were greater in the numerator, you'd have a hole at the x-axis. But that's what we have, a vertical asymptote here. X plus 5 in the denominator, minus 5 is your magic number. That's the only thing that's there. You have a second vertical asymptote. Okay, so let's take a look at our options. F of x has a vertical asymptote at negative 5 because there's a factor of x plus 5 in the denominator and no such factor in the numerator. That is true, so that's not what we want. We are not going to select that. Okay. F of x has a 0 at x equals negative 3 because there is a factor of x plus 3 in the numerator and no such factor in the denominator. That is also true, so that's not the one that we want. F of x has a vertical asymptote at x equals 3 because the multiplicity of the x minus 3 is lower in the numerator than the multiplicity of x minus 3 in the denominator. That is also true. Okay, so be careful with the wording, but it does say multiplicity of the factor x minus 3, so you have a multiplicity of 1, is lower in the numerator than the multiplicity of x minus 3 in the denominator. True statement. F of x has 2 zeros because the numerator x squared minus 9 can be factored. I mean, yeah, it can be factored to that, but this is not a 0 because it's negated by that. So D is the lie. D is the lie, which is funny because D is devil, and the devil is a liar. I hope this helps. The residual plot is the result of a model created using linear regression on a graphing calculator. A and B also represent data points. Which statement is true? All right, so if you don't understand linear models or residual plots, let me kind of show you what this is. This is supposed to represent a line of best fit. That is supposed to represent a line of best fit. Okay, usually if I have a line of best fit, I have a couple dots living above, maybe 1 or 2 on, a couple dots living below, and we would say this line of best fit represents, a line that tells us where all these dots are headed. These dots are going to continue heading up and to the right. Well, if we take that blue line and drop it down that way and remove all these dots, so that, not remove them, but change where these dots are so that now they're still kind of like hovering over these dots here. I'm trying to make the same dots. We would say, oh, okay, so like these dots live above the line, so those dots live above the line. These 2 dots live on the line, so those do too. Those 5 dots live below the line, blah, 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 blah. So a residual plot, when you have no obvious pattern, like we have here in this blue line, when the dots show no pattern, we have a good model. Like I was in college. Hand model. Now, when we look at this, see how these dots go up and almost show like a negative quadratic, a negative parabola? Well, this is a pattern. This is a clear pattern. So this would be a bad model, like I was 1 year ago when I modeled for swim trunks. So, all right, so that's one thing that we know. It's a bad model. Great. What else? We have an A living up here above the residual plot, which means like maybe you would be like an A. Somewhere over here above the line would be an A. So we would call a point like A an overestimate of the actual prediction, an overestimate. Since B lives below, we would call it an underestimate. And looking at this without looking at the multiple choices that I created on my own, looks like we have enough information to hopefully get something. So a linear model is appropriate for the data. Well, we said that this is a bad model because we see a clear pattern happening on the residual plot. So is a linear model appropriate for the data? Absolutely not. So that is not a true statement. The original data represents a negative correlation. Well, negative correlations are dots that go down and to the right following a linear pattern. We already said that linear is no good. So if linear is no good, how can it be a negative correlation? Well, I'll answer that for you. It can't. The point A is an overestimate of the model. Well, here's A, here's the model. A is over the line, so A is an overestimate. That is a true statement, C. Now, if you're looking at this and saying, whoa, 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 I see that word right there. How can the answer be C? Watch the words. The model produces an underestimate of the point B. Our words are backwards. The model is up here. B is down there. So it's not saying B is an underestimate of the model. It's saying the model is an underestimate of B. It's backwards. The model lives above B. So the model overestimates B, not underestimates B. So since the wording is strange, we have to be extra, extra, extra careful. All right? So I don't like it, but you have no choice. I'm sorry. Hope this helps. The graph below shows the polar equation r of theta equals 2 cos 3 theta graphed on the interval AB. What are the values of A and B? All right, so obviously I don't have the whole picture. If you have your pictures memorized, you know that this is going to be, since that's odd, you're going to have a 3-petal, as I think a D, a 3-petal rose-looking thing that goes out to 2. And since this is cosine, it's, and I'm not even going to attempt to try to draw this, it's going to look like that. Oh, perfect picture. But that's not what I have. I have what appears to be like 1.5 petals. So I have to kind of deal with that. So what I'm going to do is I'm going to graph what 2 cos 3 theta looks like on a rectangular plane. All right. So if it's 2 and cos, it starts at 2, bottoms out at -2, no midline to worry about. This is just a regular 3 rows. It's going to go, let me get a different color. It's going to go down and up, down and up, down and up, and have 3 cycles completed, so at 2 pi. Now, how do I know that? The frequency is 3. So whenever you're given the frequency, that tells you how many times it's going to repeat once it hits 2 pi. If you're like, I don't like looking at that, I'd rather find the period, then fine. The period is going to be 2 pi over the frequency, and you can figure it out that way. So some magic numbers to look at, okay? It repeats every 2 pi, and it repeats 3 times. So halfway through at regular pi, we're at -2 here. Okay. Halfway in between that, we hit the 0 axis. So that's pi over 2. And then we hit 0 here at 3 pi over 2. So, just in case you need the numbers there, 0, pi over 2, 3 pi over 2. Nope, that's pi. Hee hee. Hee hee hee. It's my Michael Jackson impression. And this is 3 pi over 2 over here. Now, as you can see, at 0, we're supposed to start at 2. And you might be like, oh, hooray, that's what we have. At 0, we do start at 2. However, this is having us live in positive R land and approaching 0. So it actually starts out going like this. Okay, now it hits 0, hits negative land, and hits 0 again. Okay, so like that. Now I know the picture's not really good at all, but what we know is now we need to be where we need to be. See, this part wasn't on the graph, but here we are at pi over 2, 0. So there's 0 at pi over 2, and at pi over 2, we're living in positive land. Sorry, I hit a button. We live at positive land and then come around. We are where we need to be. Okay, at somewhere here, we hit negative land and stop being negative. So as we go from pi over 2, we hit negative land and have a negative distance, which goes the opposite direction of what's going on over here. So what we have is a graph on pi over 2 to pi. I'm not even going to bother marking up the rest because clearly I can't draw any of this stuff. But tricky problem. Not a fan of it. Not a fan of it, which is funny because it kind of looks like a fan. But I personally am not a fan of it. But, hope this helps. Welcome to the calculator section. The fun part about the calculator section is you may need a calculator, you may not. And I have a feeling with this one, I won't need it. Given the function represented by the table above, what is the average rate of change between x equals 3 and x equals 7? Well, I have x and f of x. And the rate of change formula is f of b minus f of a over b minus a. You would be an a, you would be a b. So what I have to do is find out f of 7 minus f of 3 over 7 minus 3. F of 7 is 13. F of 3 is 7. 7 minus 3 is 4. 13 minus 7 is 6. And 6 over 4 simplifies to 3 over 2, which I didn't even have to do because 6 over 4 was an option. Interesting. I wonder why. But yeah, I mean, no calculator needed. You could have used one, but yeah, this one was fine without one. Hope this helps. The depth of water at the center of Lake Precalculus is modeled by a cubic function h of m, where h represents the height in feet and m represents the months of 2022. For example, m equals 1 corresponds to January and 2 is February and stuff. The data for the first 6 months of 2022 can be found in the table below. Use a cubic model to estimate the depth of Lake Precalculus in October 2022. So we care about October, which is 10. But what I need to do is it tells us right off the bat, it's cubic. That's what I was looking for. So what we need to do is we need to run to the calculator. We need to type this stuff in. We need to use cubic regression and use that formula to find what happens when I plug in 10 for m or x or whatever variable you use. Be right back. All right, let's talk about Lake Precalculus, which reminds me of my childhood. We go to stat, we go to edit, and let's plug in some numbers. The left side, pretty easy, just, 1 through 6 for January through June. Then you've got 41.6, 45, 45.8, 44.6, 42, Jackie Robinson, rest in peace, and 38.6. Now, this was a cubic model, so we're going to use cubic regression. And we're going to need to use that equation to plug in 10. So not only will I go to stat and calc and go down to cubic reg or just hit 6 or whatever your pretty little heart desires, we're also going to make sure that we go to store regression equation and save that equation because we're going to use that equation. So go to store reg eq, hit vars, go to yvars, hit function, hit enter, and now when you hit the y equals button, that gross looking formula, which is actually not that bad at all, will show up in y equals. Now, of course, if you're like, whoa, 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 they're just being a tiny bit more specific than what that home screen showed us. Now, why am I going here? Well, my job is not to find the equation. My job is to find out what happens in October. So I can go to second table and scroll down to 10 and find out that October, which is 10, is 29. Or 29.00000000000000023, which I think rounds to 29. So I'll go back and see if I can find 29.000000000000023, or if it's just 29, then I guess I'll select that one. Well, they don't have 29.000000000000023, so I guess I'll select this one. But that's how you do it. Okay, cubic reg, do the store EQ. That helps. It's not necessary, but it helps. The function was friendly enough, but it made things just a teensy bit faster for me. Of course, I wasted all that time with all those zeros, but you know what? Hey, more zeros is more YouTube money. More zeros in my bank account. Hope this helps. The graph below shows a function f of x, looks like that, on intervals 0 is less than or equal to x is less than or equal to 13. So I care about stuff between 0 and 13. That picture checks out. 5 coordinates labeled BREAD. Sounds like a word. BREAD. Yeah, it checks out. One of the 5 points coordinates represents a local maximum, so that would be u. One represents a point of inflection, so that would be U, IP for inflection, you know what I mean. And 1 point represents a local minimum, that would be U. Let T sub B, T sub R, T sub E, T sub A, and T sub D represent the x coordinates at those coordinates. So you would be, I guess, I mean, it looks like 0, but instead of calling it 0, you would be the point like T sub A something, and you would be not T sub A, T sub B, because we're going in the words, T sub R, and so on and so forth. It's kind of stupid the way they did that, but it looks like a problem on the practice test. That's why I did it this way. Of the following, on which of the intervals is the rate of change increasing at a decreasing rate? Well, if you're wondering, what the heck is increasing at a decreasing rate means? Well, a decreasing rate implies concave down. Increasing up implies going up and to the right. So increasing at a decreasing rate implies the left side of concave down. Now, the only spot that shows me the left side of concave down is in between B and in between R. You are decreasing at a decreasing rate. Now, this guy is concave up, so you are decreasing at an increasing rate, and you are increasing at an increasing rate. So this is what I want. I went between B and R, so they're not going to just be like, hey, select B and R. That's not how they want us to do it. They want us to say, all right, well, the x value for B is T sub B, and the x value for R is T sub R, so we're going to select A and only A. So where was the calculator necessary in this one? Nowhere. Nowhere at all. You will find that in the calculator portion of the AP exam, you're only going to use the calculator for about like maybe 60% of the problems, which you're like, oh, that's still more than half. It sure is, but it's not all of them. So don't go searching your calculator for something to do with this. There's no numbers except for these. It's just making sure you understand the vocabulary. Okay? Tricky, 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 weird, weird, weird. Hope this helps. Maria, you remind me of a West Side Story. Santana. Maria's bird watching and spots a bird in the air. Hi, Maria. Oh. The angle of elevation created by her line of sight and a line parallel to the ground is given as theta. So if you're like, this is the line of sight, her eyeball hitting the bird, okay, and as you can tell, and I'm not going to write it out, that's parallel to the ground. Okay, you are going to be called theta. If tan theta equals 4/3, so tan theta equals 4/3, what is the slope of her line of sight? You ready to get out your calculator? Don't be. You don't need it. Tangent, by definition, means slope. When you get to calculus, one of the first things that you will learn is tangent means slope of a line at a point. Okay, so when it says the tangent is 4/3, that is the exact same thing as saying the slope is 4/3. So the slope of her line of sight is 4/3. And you're thinking, no way. There's no way this problem is as easy as saying tangent's 4/3, slope is 4/3. Yes, it's exactly that easy. Tangent means slope. Tangent means the change in the y values over the change in the x values. So this problem is done. No calculator necessary. That is it. Hope it helps. A data set is shown on a semi-log plot with a vertical axis scaled logarithmically. Okay, well, I don't see the semi-log plot. The points on this plot appear to demonstrate a consistent linear increase. Which of the following types would best represent the data set? Okay, well, I don't have a picture. I have a calculator, but I don't need it. If you have a semi-log plot, and I'm not even going to attempt to really draw this, but you might remember semi-log plots kind of start out here and then things kind of like, simplify or get closer to that, and then this happens, blah, 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 blah. Well, if on a semi-log plot, you have dots going up and to the right, that does not indicate a linear equation because semi-log plots, their vertical axis are scaled logarithmically. So, and it says that right there. So this is not linear. What you have going on is exponential growth. Now, semi-log plots, when graphing linear-looking equations, give you either exponential growth or exponential decay. Why do I have growth? Well, this is going up and to the right. If these dots were going down and to the right, then you would have exponential decay. Okay? If these dots look like this, then we don't have exponential growth or exponential decay. And you're thinking, but it looks like exponential growth. I know, but if it's graphed on a semi-log plot, it's not because everything is scaled differently. So it's not quadratic. That's just a throw-in option that I gave you. But it's either going to be exponential or exponential. And in this case, it's exponential growth. So another one of those problems, that's a calculator section problem. Calculator wasn't necessary. We didn't even have a picture, but we didn't need one because my art did the job just fine. Hope this helps. A particular bank offers a newborn account promotion that gives the family of a newborn a $100 account with a biannual compounded interest rate. The formula the bank uses is A of y equals 100 times 1 plus r over 2 to the 2y. So this is a typical compounded interest rate formula. If you have heard of the continuously compounded interest formula, there's similarities. Okay, but this is not the continuously compounded interest formula. This basically says, like, I put $100 into the bank and I check a half a year later and I have a little bit more. And then I check 6 months after that and I have a little bit more. But we really don't need to worry about that. What we need to worry about is A of y is the total amount of money that you have in the account, not how much you make, your value of the account. R represents the interest rate as a decimal. So if your interest rate is 2.5%, you move the decimal to the left twice, and R will equal 0.025. Okay, we'll get there when we have to get there. Y represents the years the account has been used. Okay, so everything so far gross but makes sense. If an account opened for 13 years has the amount of $108.52, what would the average rate of change be from the 14th year to the 18th year? This is going to be a nightmare, but I'm here to guide you. First things first, I don't know what R is, but in this part, I can take T. Well, I'm sorry, Y is 13. Usually I use T for these problems, but Y is 13. And this would be A of Y and set up an equation. So 108.52 is going to equal 100 times 1 plus R over 2 to the 2 times Y, which is 2 times 13. I could do two things right here, so I'll do both of them. I could divide both sides by 100. So now I could do this in my head. That's just going to be 8.52. I mean, you could use a calculator, but the numbers are friendly enough where I could just do that. No, it won't. It'll be 1.0852. Ugh, silly me. I can divide this in my head. I mean, dividing by 100 just has you move that over twice. So that becomes 1.0852. You could use your calculator, but I don't want to have to go back and forth when I make these videos. 1 plus r over 2 to the 26th. All right, now let me take this guy and rewrite it over here with all of this space. We are going to do something that you've probably never done in class. Maybe you have, maybe you haven't. But my issue right now is I have an r trapped inside a parentheses. I need to bring this 26 down. Somehow I need to bring it down. So this is what I'm going to do. I'm going to ln both sides. By ln'ing both sides, I can bring that 26 out in front. So now I have ln of 1.0852, whatever that is, equals 26 ln of 1 plus r over 2. There you go. Now what I can do is I can divide both sides by 26. Cross you out. That leaves me with, and this is awful, ln of 1.082 divided by 26, 0852 divided by 26 equals ln of 1 plus r over 2. Let's run to our calculator and find out what ln of 1.052 is divided by 26 real quick. All right, ln of 1.0852, close it, divided by 26. Enter is going to be 0.0031, blah, 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 blah. So I'm going to actually write out as many of those points down when I go back and do the problem. All right, let's move everything up here, cut you off. Right there, we have ourselves. And actually, let me erase this to give myself more space, because even when we finish this and find out what R is, we are certainly not done yet. It's a gross, gross, gross problem. We ended up with 0.00314478. I'm going to write out all of that. Does it seem like a lot? Do I care? No. That's going to equal ln of 1 plus r over 2. Now I need to unlock that r. So what I'm going to do is I'm going to e both sides. So you're going to be e to that gross number equals that. That allows you two to cancel each other out. So I have e to the 0.00314478 equals 1 plus r over 2. Subtract 1 from both sides. Equals r over 2, and multiply both sides by 2, and you can now find your r. Okay, so that looks awful, but I'm going to run to my calculator and find out what 2 parentheses e to the 0.0 minus 1 is, and that gives me r as a decimal. Be right back. All right, here we go again. 2 parentheses. The e to the is that button right there. And it's going to be 0.00314478. Okay, let's hit right. Let's subtract 1, close it, hit enter, and we get 0.006299. So let's do that. 0.0. Let's do the whole thing. Freak it. Freak it. Let's do the whole thing. I apologize for my vulgar language. The rate as a percent is, or not as a percent, as a decimal is 0.006. Actually, the numbers, I know I said freak it a bunch of times, but let's keep it like that. 63. So that's basically 0.63%, not a strong rate. Now, this is what I have to do. Now that I know that r is this, I'm not even done. I have to run to my calculator. Let me get rid of this mess up here, blah, 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 and let me use this equation in my calculator. 100 times 1 plus 0.0063 over 2 to the 2 y. We're going to use that to find the average rate of change from the 14th year to the 18th year. So I don't have to go back and forth a ton of times. I'm going to do that formula, find out a of 18 minus a of 14 over 18 minus 14, which is 4. So this is going to give me some terrible number, okay? Divide that by 4, and that'll see my average rate of change. It's not going to be a lot, but let's see what happens. Oh my gosh. So let's graph that terrible, terrible, terrible equation. 100 parentheses 1 plus parentheses 0.0063 divided by 2, close it, okay, to the 2, I know it says y in the problem, but it's to the 2x. Okay, so just making sure everything looks good. The graph won't help us. What I need to do is find out what a of 18 is and a of 14 is. So let's go to my table. A of 18 is 111.99. What a convenient number. 111.99. And a of 14 is going to be 109.21. So let's go back. Parentheses, 111.99, 111.99 minus what it was 14, 109.21. And we're dividing that by 4 because of 18 minus 14. 0.695. Now this is money, so 0.695 means 70 cents. So after all of that, well, let's go back and I'll explain what the problem is. We'll select 0.70 and we'll explain what the answer means in this context of the problem. All right, so B is our guy. So after all of that, what this means is this bank account that you're given for free is only going to get you about 70 cents a year once you hit your teenage years. That's not a lot. And banks kind of work that way. They kind of rip you off. Okay, so, store your money in treasures in heaven. I think the Bible says that, but, whatever. So that's this problem. This problem is like, here's an account. If you're a 13-year-old and you only make $8 after, you started out with 100, what are you going to expect to make, like $100 a year? No, in this case, it's 70 cents. So terrible, crazy, terrible problem. But we got through it. So hope this helps. A particle is moving along a curve and its position is given by s of t units. The velocity, also known as the rate of change of the particle, is given by the equation v of t equals 0. Blah, 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 blah. For t is between 0 and 14, but not including. I probably could have included those. Doesn't make a difference. Which of the following is true about the position of the particle? This is a problem that I made and I was inspired by calculus. They love to give you the particle velocity type questions. And this is what the question is asking. It's giving you the velocity function, right? Now, the velocity of a particle is also its rate of change, also its slope. So we have to understand that if the velocity, okay, also known as the rate of change, also known as the slope, if the slope is negative, okay, if the slope is negative, that means its position has a negative slope and its position is going down. Now, what that means with a particle is a particle can like go up, down, what we don't know. But if the velocity or the slope is negative, the position means it follows a negative slope. It's going down. If the velocity, also known as the slope, is positive, okay, that means its position is following a positive slope, so it's going up. So there's two things that we're looking at here. Okay, one thing is this picture that I kind of drew here. So thing number one is if you have a negative velocity, a negative v, and then all of a sudden it changes to a positive velocity, positive v, you have yourselves a minimum. Okay, you have yourself like, okay, well, here it is. If the particle's moving along at a position, that's what happens when your velocity or slope changes from negative to positive. Similarly, if our velocity goes from positive and then all of a sudden changes to negative, we have ourselves a maximum, local maximum. So maybe something like this. Okay, so what we have to do is we need to graph this. We need to graph the velocity function and find out where it's positive and find out where it's negative and find out where that change is. Okay, because if it's positive and then becomes negative, then it looks something like this. Positive slope, negative slope, we have a maximum. If it's a negative slope that changes to a positive slope, we have a minimum, and we could probably answer these questions here because these answers are talking about zeros and local minimums and maximums and stuff like that. So let's run to our calculator and see what happens when we graph that guy right there. All right, so we are looking at graphing that velocity function, which was pretty unpleasant, but we'll be all right. 0.765, it says t, but t is x, minus 2.654. 2.654. Now, before I even graph this, we care about magic happening between 0 and 14. So let's change our window from 0 to 14, like so. Let's hit graph. Now, remember what I said on this slide. When you have a negative slope, that means your actual function is going down. When we have a positive slope, that means our actual function is going up. So here is a negative slope, here is a positive slope, and we should probably find out where that changes. So second calc 0 will tell us where our slope, or this velocity function, which is the slope, changes from negative to positive. So if we put the left bound to the left of it, put the right bound to the right of it, and hit enter for guess, we have 3.469 or 3.469 is where our slope goes from negative to positive. So let's go back and try to diagnose what that means. All right, so as you can see from the multiple choice options, 3.469, the number that we saw in the calculator, is going to help us out. What we saw in the velocity graph that we drew in the graphing calculator, or saw in the graphing calculator, is the slope went from negative to positive at that 3.469. Okay, so that 3.469 is telling us that we have something that looks like this, so I can get rid of you because you're no longer a viable option. We have a position where this particle is like traveling down some type of roller coaster and hits the very bottom at time 3.469 and then goes back up again. So this is a local minimum at 3.469. So the particle's position is 0 at 3.469. No, that's not true. The particle's position is at a local maximum at 3.469. Nope. The particle's position is at a local minimum at 3.469 because the velocity, also known as the rate of change, changes from negative to positive at that value. That's my guy. The particle is always increasing because the velocity is always increasing. No. The velocity always increasing has nothing to do with where your position is. It just means you're speeding up. And if you're going down a hill, you're probably going to speed up at some point. So yeah, there you have it. Very strange problem, very different problem. But, this problem mirrors a similar problem on the second or AP classroom practice test, whatever it's called. So yeah, I'm not just pulling this out of thin air. It's something that you could possibly see. So hope this helps. Certain points of a rational function g of x are displayed in the table below. Which of the statements is true about g of x? Well, let's see what we have. We have x values that go up by very small increments. And as the x values go, and it looks like this is pretty consistent, they go up by 0.1 every single time. Okay. This goes up by 0.2 every single time, except for right there where it's undefined. Now, what that tells me is you have some type of graph that it goes up 2 over 1. So you have some type of graph that goes up 2 over 1, and then all of a sudden it blanks out at 4. Now, if something is undefined, you're looking at two options. Option number 1 is a vertical asymptote, and option number 2 is a hole. Now, with vertical asymptotes, this is what you're going to see. You have two options for vertical asymptotes. As things get closer to that magic number, these y values, in our case, g of x values, are going to explode, and then all of a sudden just reappear down there at the bottom. Or if your multiplicity is 2, your numbers are going to explode and then level out. That's not what we have here. We don't have a picture like that. What we have is a picture where if it's a hole, things seem pretty consistent until all of a sudden it's undefined and then it keeps going. And that's what we have. This stays very consistent. It's very linear until all of a sudden it's undefined, which tells me at 4 you have a hole. Okay, so not a vertical asymptote, not a horizontal asymptote. Yes, a hole, and not a 0. If it was a 0, this would say 0. But again, what vertical asymptotes are going to do is this number is going to be regular and then a little bit bigger and then a little bit bigger, then huge. And usually when they give you graphs where it gets huge, they'll say stuff like, 3.9 is like 100, and then 3.99 is like 1,000, and then 3.999 is like 10,000, and then all of a sudden 4 is undefined. So that's usually the vertical asymptote type problem. We didn't have that at all. This is a hole type problem. Where did I need my calculator? I didn't. Once again, this is one of those problems where you don't need a calculator even though it's in the calculator section. Okay? Hope this helps. The table below represents values of a logarithmic function. Look how small it is. Why did I make it so small? Use logarithmic regression to predict the y value when the x value is 654. Geez Louise. All right, so what I'm going to do is I'm going to use that table right there and use what's called ln reg. What that's going to give me is that's going to give me some gross-looking ln problem. I'm not going to write it down. I'm not going to save it. I'm just going to store it and then plug in 654 and see what happens. Be right back. All right, ln reg is just like any regular regression, okay? You go to stat, you go to edit, you type in your numbers. Now, you know this is logarithmic because you'll see as I type in the x values are multiplied by 4, okay? And the y values just go up by 2 every time. That's what makes something logarithmic. If the y values increase by the same constant number for every equal value interval and the x values explode, that's logarithmic. The reverse of that would be exponential. Now I'm going to go to stat, and ln reg is 9, so you can either hit 9 and scroll down to it, whatever you want to do. For store regression equation, I'm going to go down and I'm going to go to vars and store this. So vars, y vars, enter, enter. And now when I hit calculate on this guy, I don't have to write this whole mess down. Now, usually when I do problems like this, and let me go to y and just show you what I mean. Usually when I do problems like this, I go to my table and I scroll down to see what I need. Well, in this case, I'm looking for 654. So if you're thinking, oh, I'll just find the values, second calc value, that's a great idea. Here's the problem. If you type out 654, it's going to yell at you. It's only going to give you the values that the table covers. So I need to change the window to make sure that I have 652. So I'll change it to 700, not 100, 700. Hit second, calc, value again, type that number 654, hit enter, and I get 17.35, blah, 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 blah. So that's what I'm going to get. I'm going to go back, select that answer, and I'll be done with it. 17.345. Yeah, I wonder if maybe I put in one of these wrong, or if maybe when I created this problem it was slightly off, or maybe, I don't know what I did wrong. But clearly this is the answer that I want. Maybe I just mistyped it. But yeah, there you go. ln reg. Fun stuff. Hope this helps. The polar function f of theta equals r equals 2 minus 3 sine theta is graphed in the polar coordinate system on the interval between 0 and 2 pi. On which of the following intervals of theta is the distance between the point with polar coordinates and the origin increasing? All right, so this is what it's asking. This is a very confusing problem, but let's try to understand what the question is asking us. If you were given a polar graph, right, and you start graphing the polar graph, and you start way out here, and as you move counterclockwise, it moves its way in, your distance is decreasing. Now, what that looks like, okay, so again, as you move counterclockwise, this curls in, you're decreasing. What this looks like on the rectangular system is you start up here and you work your way down, okay? As you move towards the x-axis, you're decreasing. What that also means is if you were to draw this out and keep drawing this out, this too is you working towards the x-axis. So you could be in negative land, you could be going this way in negative land, working towards this, and that's you also decreasing. So if your graph in the rectangular system is moving towards the x-axis, your point is decreasing. That's not what we want here. We want increasing. So what that could look like is maybe you have a polar graph and maybe you start at 0, 0, and as you move clockwise, it kind of gets larger like that. What that looks like is, again, you start at 0, 0, and you're moving away from the x-axis, okay? So that is an example of increasing. So we need to find out where we're moving away from the x-axis. Okay, so it could look like that, or it could look like that. Okay, so we're going to run to our calculator. We're going to graph this guy out. Okay, and we are going to find out where our curve is moving away from the x-axis. Here we go. All right, you ready? We are going to graph 2 minus 3, was it cos? Sine. Ooh, that was a close one. Sine and an x, because we're graphing this on the rectangular system. So I'm going to change my window. Actually, I'm going to go to zoom and do zoom trig and then change my window. All right, so as we can see, it bottoms out at -1. It looks like it goes up beyond whatever this number is. So I'm going to go and say, let's move this from -2 to, I don't know, 6 should probably do the job. Also, I care about stuff happening between 0 and 2 pi. So let's change that to 0 and 2 pi and hit graph again. Now, what I said is we care about where things are moving away from the x-axis. Interval number 1 is going to start from here and end here, because at this small, tiny curve, we are moving away from the x-axis. So I need to see what that is. So that is a 0. I'm going to hit second, calc, and go to 0, which is the second one. I don't know why it took me forever to look for that. So let's scroll over. Hit enter. And it begins moving away from, it begins increasing, I guess I should say, at 0.72, blah, 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 blah. And it's going to stop increasing right here at the minimum. So let's do minimum. Boom. Let's move to the left. Hit enter. Move to the right. Hit enter. Hit enter. And we get 1.57, which is half a pi. So it looks like magic happens from 1/4 of a pi, that 0.7 to 1.57. So that's our one thing, 0.7 to 1.5. Okay, I'm not going to have that memorized. You'll see it when we get back there. Now it starts increasing again from here to here. So I need to find that 0. So I'm going to repeat the process. Second calc 2. Okay, find that 0 right there. Enter. Enter. So 2.4 whatever, okay, is where I start increasing again, and it stops increasing at that maximum. So second calc maximum. Let's move to the left. Enter. Move to the right. Enter, enter. 4.7. So we add like 0.7 to 1.5, 2. I don't remember, to 4.7. Let's go back and answer that. All right, so I hope your memory is pretty good, but that's the guy we got. Okay, so again, the picture that this looked like is from 0.7 whatever to 1.5 whatever. It looked like that, and then it came back up and went way up here at 2.4 to 4.712. So C is going to be our guy. Very tricky, very challenging problem, but again, all the problems that I make are taken kind of from the test with changes. Okay, so I hope this helps. A pot of water is placed over a fire until it begins to boil. The function T of m equals 2.169 sine inverse of 0.132 m plus 0.77 gives us the temperature of the water, T in degrees Fahrenheit and hundreds, from the time 0 to 5 minutes. Awesome. Gross. Approximately how many minutes will it take the water to reach 100 degrees Fahrenheit? So this isn't so bad. We're going to graph this in our graphing calculator in y sub 1. Now, since the temperature is given in hundreds, in y sub 2, we are going to graph 1.5 because 1.5 hundreds is 150. I'm going to find out where these two guys intersect, and that's going to give me my minutes. So let's go and do that. Okay, you ready to... All right, y equals 2.169. Inverse sign is second sine. There's my inverse sign. 0.132x. So I'm going to make sure I hit that. Close it. Plus 0.77. The other graph that I said I was going to make is going to be 1.5. Okay, so let's hit graph and see what happens. Okay, so we get right there almost right away our intersection. We need to find out where they intersect. So second calc, 5 takes us to intersect. Let's move just to the left, enter, and just to the right, enter. Hit enter again, and we get 2.50183, blah, 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 blah. So x is going to be that 2.5 answer. Let's go back and circle it. All right, 2.501 stuff is going to be 2.502 once I round it. So pretty weird problem, but not too bad. Just use your calculator. Hope this helps. The last problem of the calculator section, and the MCQ, as the kids say. The graph below shows the rate of change of profits for a particular store in thousands of dollars for the first 8 hours that the store is open. Which of the statements can be true based on the graph? So let's look at the graph. Now, this graph is not profit. This graph is rate of change. Okay, and what it looks like here is we're dealing with if I'm thinking rate of change and I'm looking at words like increasing and decreasing and stuff like that, I'm thinking concavity. So let's remind ourselves what concavity looks like. This is concave up. Concave up is when the rate of change is increasing. This is concave down. Concave down is when the rate of change is decreasing. So when I look at this picture, okay, my rate of change starts out concave up, and then it looks like, let me get a thicker line. I meant to get a thicker line. I just missed it. It looks like it's concave up until like right at 2, where we hit an inflection point. Rate of change is increasing when it's concave up. Rate of change is increasing when it's concave up. Then all of a sudden it's concave down until 4. So this is decreasing. Now it repeats the process. The rate of change is concave up, so this appears to be increasing right here. The rate of change is increasing, and then the rate of change is decreasing from 6 until the end. So the rate of change increases from 0 to 2 and 4 to 6. The rate of change of profits is increasing from 0 to 2 and 4 to 6, and the rate of change is decreasing on intervals 2 to 4 and 6 to 8. C is my guy. No calculator needed. Pretty gross problem, but boy was it fun. It really wasn't. I hated it. But, as always, I hope this helps. All right, here we are at the FRQ, as they say. There's 4 of these on the practice test. There's 4 of them on the real test, too, and this one is designed to look like the ones that you would see on the practice test. So the function g is graphed below. Looks like we got ourselves a nice little asymptote. Stuff like that. G of x has a vertical asymptote at x equals -3. I can see it. And 2 labeled coordinates, -1, 2, and 1, 1. Additionally, f of x is defined by the function f of x equals 6 over x squared minus 9. So we got 2 different things going on. We have g of x, which looks like this, and f of x, which looks like that. Lock that in. A part 1. K of x is defined, it's also designed by me, and defined by k as f of g of x. F of g of x. So k of -1 is us trying to find f of g of 1, and let me put that as a different color. F of g of -1. Oh, that was a close one. When I made a video of these last time, I accidentally plugged in the wrong number. I got a lot of comments on it, so I almost did it again. Oops, Britney Spears would say, because she did it again. So g of -1. What is g of -1? Well, g comes from this guy, and g of -1 is 2. G of -1 is 2. So g of -1 is 2. So now I have to find f of 2. F is defined as x over x, 6 over x squared minus 9. So f of 2 is going to be 6 over 2 squared minus 9, which simplifies to 6 over 4 minus 9, which simplifies to 6 over -5. But since I'm running out of space, let's just throw the negative out there and say that that is our answer for A. So let me just wrap it up. K of -1 equals -6 over 5. Bada bing! That's A part 1, or I. Part 2 is asking you to find all the vertical asymptotes of f of x, or indicate if there are none. F of x is given to us by that. Vertical asymptotes exists when the denominator is equal to 0. So x squared minus 9 equals 0. 2 ways you could do this. You can add 9 to both sides and square root, or you can factor this out. X plus 3, x minus 3. The zero product property has me setting each parentheses equal to 0, or as I know by now, the magic number for that parentheses is going to be -3, and the magic number for that parentheses is going to be +3. So I'm going to write out that the vertical asymptotes are x equals -3 and x equals +3. Now, I'm writing them both out because the vertical asymptotes is technically a vertical line. X equals -3 and x equals regular 3, I think would just be the proper way of writing it out. All right, so part one, or problem one, part A, complete. That's 2 out of the 6 parts that you're going to see on this guy. Part B, problem 1, same exact question above, don't need to repeat it. Find all the values of x as decimal approximations for which f of x is equal to -4.1. So what I need to do is I need to take that guy and I need to find out when it's equal to -4.1, and that's going to require our calculator. The first 2 problems of the free response question are calculator problems, and I'm going to want a calculator for this guy. So let's go over there. And before I go over there, let me explain what I'm going to do. Okay, I'm going to type this first guy in to the y equals part. And so, I'm pretending that this is a TI-84 plus. And in the second line, I'm going to type this guy in and find out where these guys intersect. Now I'll go over to the calculator part. All right, let's graph these puppies. I've got my first equation being 6 divided by, make sure you put the entire denominator in parentheses, otherwise your calculator will not know what you're talking about. OTI-84 plus, you're very reliable. Not joke. Now, we were supposed to solve when this guy was equal to -4.1. So I'm doing systems of equations stuff right here, and I'm doing -4.1 to the other one. When we hit graph, we're going to see a blue line and a red line cross. My gosh! Not only do they cross once, they cross twice. Who would have thought? Well, what I have to do is find out where these guys intersect. So I'm going to hit second, trace, and I'm going to hit 5 for intersect. Let's do the one on the left. So I'm going to move to the left, and I'm going to hit enter, and then I'm going to move to the right for second curve and hit enter, and for guess, hit enter. And it's going to tell me that one of my x values is -2.7452, blah, 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 blah. Okay, now since this was like a pretty looking denominator, and we found out that the vertical asymptotes were 3 and -3, we probably know what the other x value is going to be. But listen, I get paid by the second, so why don't we keep going? Let's hit second trace again to go to calc, go to 5 again to intercept, and let's find the other one. To the right, to the right, to the right. Cupid shuffle. Remember that? Remember that dance from like 2008? Hit enter again, hit enter for guess, no sign change. What did I do? All right, let's try it again. Trace, second trace. I thought I hit intersect. So, you know what? I think I know what I did. I wonder if I accidentally jumped over to that graph. This is a good mistake that happened. Enter. Let's move to the right, just barely. Enter, enter. Yeah, and that seemed to work. So as you saw, when I tried finding this one, it yelled at me and said, no, you did it wrong. I wonder if by moving right too many times, it tried to find the intersection of the red line and this part of the blue line, which there is none. So, a happy little mistake occurred. But we got what I figured we'd get, 2.745. So we get the negative version of that and the positive version of that. So let's go back and write it out. All right, so as you saw when we tried to do the graphing part, we got 2 of the same number basically, but one's positive and one's negative. So x equaled -2.745 and positive 2.745. And again, the fun thing that happened there is we had a little error pop up when we tried doing it. And it's always kind of good to play around with your calculator and see when things screwed up. And it did there, and we kind of probably figured out why. But, happy little mistake. TIs are not perfect. Not the wrapper and that calculator. If you don't know what I'm talking about, there's a wrapper named TI. That was problem I, BI. And now let's do BII. So determine the end behavior of f of x. So again, that's this guy here. as x increases without bound. Now, what does that mean? That means the limit as x approaches positive infinity. The limit as x increases without bound means x is going to keep going to the right, to the right, to the right, Cupid shuffle again. Now, if it said decreases without bound, it would be negative infinity. The fortunate thing about this is the answer is going to be exactly the same. Now, I'm not going to run to my calculator. Maybe you remember what the picture looked like, but I'm going to do this without the use of a calculator, without the picture. Okay, f of x is given to us as 6 over x squared minus 9. What you do when you're asked to find the limit as x approaches any infinity of a rational function is you take the leading term of the numerator and the leading term of the denominator and simplify it. And if you're like, it won't simplify, you're absolutely right. If the denominator's degree is higher, you're always going to get 0 no matter what. And that's because if you keep plugging in numbers, like if you plug in 5, you'll get 6 over 25. That's like point something. If I were to plug in 10, you get 6 over 100. That's going to be 0.06. Plug in 1,000, plug in 10,000, plug in 1,000,000. You're going to get a really, 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 really small number like 0. It's never going to hit 0, but it's going to be close enough where you can finally say, you know what? I give up. The limit as x approaches infinity of f of x is going to equal 0. So that's how you find out the end behavior as f increases without bound and expressing it in limit notation. So there you go. Isn't that neat? Limits. All right, part B, Denzu. Part C. The function g is oh yeah, it's the same one. I don't need to do this. All right, so this is what g looks like. Again, we've got very similar kind of to what we just saw in f, but this one only has one, okay, vertical asymptotes. It's asking if g is invertible. Now, what does invertible mean? Invertible means, can you find the inverse? Okay, now the inverse exists if you can take what's called the horizontal line test. Now, the horizontal line test says if I were to take a line, and let's put a line there. I tried to, it wouldn't let me. Let's see if it will do it again. If I could take a line, do I have a line? I hit the button. Let's try it one more time. Can I take a horizontal line and pass it through the red graph and have it hit more than once? So, no. Now here, I have a horizontal asymptote, which means it doesn't pass the red line more than once. No. So the quick answer to this, guys, is G invertible? Well, the answer to CI is yes. Now, here's the frustrating thing about the AP exam. Part 2 is asking to give a reason. Using the phrase, yes, because it passes the vertical line test will not fly for the AP exam. Why? It just won't. Remember, if you have a regular function, okay, its inverse is when the x's and the y's swap. So what we could say is for every y in g of x, each y is mapped to exactly 1x. What that means is, if you're remembering like things like these, like what were these called? Mapping diagrams, and you were asked, this is back in 8th grade, you were asked to find out if something's a function, you would be like, no, it's not. Well, now I kind of care about it in the opposite direction, right? Well, every y is mapped to exactly 1x. Now, why does that matter here? So, when taking the inverse, right? When you take the inverse, every x in G inverse is mapped to exactly 1y. That's not how you spell exactly. Exactly 1y. So again, if I were to pick, like, I don't have points, but there was another problem that I did where I gave you points. And so if you had points like 1, 2, 2, 4, 8, 6, right? If this was g of x, and I were asked you to find g inverse of x, okay, you would say 2, 1, 4, 2. You would flip the x and the y, right? And as you can see, once I flip them, the x's don't repeat. Well, that's what's going on here. Since the y's don't repeat in this picture, once I flip them, the x's won't repeat in the picture. So that's problem 1 in my ultimate practice test. It's designed to look like problem 1 in version 2 of the practice test found on AP Classroom. Is it the same? No. Is it similar? Yes. So if you were to watch this and do that, you'll primarily get a very similar thing. Okay? So that's it. Hope this helps. The second FRQ in 4 problems that we're going to see on every AP Precalculus exam is about an object launched straight up with an initial velocity of 19.6 meters per second from a height of 58.8 meters. The table below gives 3 data points displaying time after the object is launched in the air in seconds t and height h of t. So after 1 second, the object is that high in the air. After 2 seconds, it's that high in the air. After that seconds, it's that high in the air. So you can see that this guy is, shot up at 58 and then comes down, hits the ground at some point. Okay? Looks like I'm trying to draw a hangman, and that's not what I'm doing. The object can be modeled by the equation. Oh, it's quadratic, like I guessed it would be. Use the given data to write 3 equations that can be used to find the value for constants a, b, and c in the expression for h of t. So a, I, scares me because of artificial intelligence. Use the given data to write 3. Did I say that already? I think I did. So I have to write out 3 equations using this information and using that information. I don't have to solve it. I don't have to find it. I just need to write it out. So if your t and your h of t, one of my equations is h of t is 73.5. So I'm using this information right here, equals a1 squared plus b times 1 plus c. That's one equation I could use. The other equation I could use is 78.4 equals a2 squared plus b times 2 plus c. And the third equation that I can find is going to be 34.3 equals a5 squared plus b squared plus b times 5 plus c. 3 equations, 1, 2, 3. Check, check, and check, baby. Now let's do the double I. Okay, the double I. Find the values for A, B, and C as decimal approximations. Well, we know that this is a calculator problem, so what I can do is I can run to my calculator and use quadratic regression. Okay, so let's run over there and do just that. All right, quadratic regression, just like any regression, starts with you going to stat, hitting edit, and plugging in the values that you had. The one value that we had, well, the 3 x values, or in our case, the t values were 1, 2, and 5. That matched up with 73.5, 78.4, and 34.3, respectively. All right. We need to do a quadratic regression. So stat again, calc, and quad reg is number 5. So go down to 5 or hit 5. And usually when we do this, we would go down to store regression equation and save that. I'm going to show you how to do that just in case you've never seen it before. Vars, you go down the store reg EQ, go to vars, y vars, function, enter. And then what that's going to do once I hit calculate is save that in here. Now, normally I would do that, but when I go back and forth when making these videos, every time I go back and forth, I lose all this information anyway. But that's all right. I'm going to hit calculate. And this gives me exactly what I need. And if I were to use the equation later, there it is. It's a mess, but negative 4.900000 is basically the same thing as negative 4.9. So negative 4.9, 19.6, C is 58.8, and it gives it to us quite nicely. So that's all we have to answer it. We just have to say what A, B, and C is. We don't have to build the equation ourselves. So let's go back and do that. All right, so using quad reg, we were given A equals 70, nope. Okay, so using quad reg, we were given A equals negative 4.9, B equals 19.6, and C equals 58.8. And if your teacher ever had you do any gravity problems, these numbers should look kind of familiar, especially that guy right there. I mean, that guy gave us our height, which is that guy right there. So it all worked out nicely. So that's part A, writing out useless equations, but actually finding the equation that we would need. B is a three-parter, and B part 1 is asking us to use the given data to find the average rate of change from times t equals 1 second to t equals 5 seconds. Now, there's two ways you can handle this. You just came up with an equation. You could use the equation in your calculator to do the math for you. But what I'm going to do is the fact that it gave us t equals 1 and t equals 5, and look, t equals 1 and t equals 5. So the average rate of change is given to you by the formula h of b minus h of a over b minus a. You would be my a, you would be my b. So h of b would be the same as h of 5, which is 34.3. H of a would be the same as h of 1, which is 73.5. And that's going to be over 5 minus 1, so over 4. Now, I'm not going to waste time going to a calculator and trying to find out what that is. I'm just going to wave my hands and tell you right now it's negative 9.8, which just so happens to be, never mind, negative 9.8. Let's just leave it at that. Okay, so that is B part 1, part I. Use the average rate of change found in I to estimate the height of the object at time t equals 3. Well, what the average rate of change does is it says if we were to start somewhere, if we were to go somewhere, how much is this changing per interval? What this is saying is from beginning to end, or at least from 1 to 5, this goes down by 9.8 feet, or what is it, meters? 9.8 meters every second. Okay, so if we're saying, all right, well, let's estimate 3 at 1, at t equals 1, we get 73.5. So if for every second we go down 9.5 or 9.8 meters, let's subtract 9.8 and then 9.8 again. That gets us to 2 and then to 3. And by doing that, we get 53.9. So estimate the height. So 53.9 meters. I probably should have said up here that this is meters per second. Okay, so let's just add another box right there. Look at that. All right, compare the estimate found in 2 to the value given by the model h of 3. So what I need to do is let's go back to our calculator. Let's use the model that we had, the equation that we had, and compare h of 3 to 59.3. And then, all right, so like I said, once I get rid of the calculator, it goes away. So let's type out negative 4.9 x squared. What was it? Plus 19.6 x plus 58.8. Now, we are being asked to compare this guy where x is 3. So I can find out easily where x is 3 or t is 3 by going down the table and getting 73.5, right? Now, how come in the last one we got 73.5, and now for this guy, or for the other one, we had 53.9? Why is it so different? Well, the actual picture that we're dealing with here, and let me hit zoom fit so I can see the actual picture. And if you're wondering, like, where is zoom fit? Zoom 0. The actual picture is this. Now, let me actually go to the window. I don't need negatives because this is a real life problem. So let me get rid of the negatives. Okay, let me get rid of all the negatives. That's the picture that we have. So we shoot off this object. It goes up in the air and then drops down. Okay, it goes up in the air and drops down. That's the actual object that we get. When we did the average rate of change, we just went from here and said, let's go down and let's go down, and here we are. Okay, but what's actually happening is we have something that's parabolic. It's an upside down parabola. So if I were just staring at the numbers when I found the average rate of change doesn't realize that I'm actually going up and down. It just thinks I'm going down. Okay, so that's why there's a difference between the two. Now, just knowing the problem that I have ahead of time, what I'm also dealing with is if I hit second calculate, or if I hit second table, we start out at 58.8, and exactly at 6 seconds, we hit 0. What does that mean? That's the ground. At 6 seconds, we hit the ground. So I'm just going to use this to help me find part C when I get to part C, but we're going to answer both of those parts by just looking at the picture that I have here. So let's go back and do that. All right, so what I did using the graphing calculator is I found out that the actual picture looks like this. Okay, by finding the average rate of change, it only assumes that that's what we're dealing with. So the way that we're going to describe this is h of 3 is actually equal to 73.5. Okay, so, but the estimate we found was, what was it, 53.9? The difference is because the model is quadratic, and since I'm running out of room, I'm going to say average rate of change doesn't factor that. It doesn't realize that. It just thinks it's a negative slope because you're just using 2 points. All right, so that's the difference between the two. There you have it. Now, what we saw in the picture is going to help us explain part C, which is how the range values of the function should be limited by the context of the problem. Now, the range values, and actually I was thinking it was domain values, but this is the range values. The range is going to be, and actually, you know what? I do need to go back to my calculator and find out what the maximum is. I think it actually might be that, but I might have to just go back there and find out what the maximum is. So I regret everything. Let's go back and do that. All right, I'm going to spare you and not make you watch me type in these values again. If I have to find the maximum, let me go back to window. Let's make this, I believe it was 0. All right, let me spare you and not make you watch me type this out again. Also, I had to fix my window to what I think should be fine. So when I hit graph, yeah, that works out okay. Now, once the range values. Okay, so the range values are going to be from 0 all the way up here. So let's hit second calc to find out what my maximum is. So 4 is my maximum. Go to the left, hit enter. For right bound, we're going to go to the right, hit enter again. And the maximum is 1.99999999999. So probably 2. So now that we know that the maximum is 78.4, which happened at 2, we can go back and say that the range is from 0 to 78.4. So let's do that. Ugh, back and forth, back and forth. It's like me having a conversation with my father who has different political opinions as me. I'm just joking. He doesn't talk to me. That's the maximum, as we found. So the range is, we'll say you're allowed to include 0, and we were allowed to include 78.4 because that represents the height of the object in the sky. The height of the object. So you can't have negatives. And you can't have anything greater than 78.4. Or anything larger than 78.4. All right, so that's why, because you have an object, you're shooting into space, you can't go greater than the thing that you get. You can't go to infinity. You can't go to the negatives because that would be underground, which is just silly. So that's problem 2. After this, we get 2 more, and no calculators allowed. Baby, hope this helps. Problem number 3 in the free response questions. Problem 3 is always going to be sinusoidal, and pretty much every single practice test I've seen has a picture that looks just like this. So whether you're going to be given a problem about a Ferris wheel or a grandfather clock or a pendulum or something swinging back and forth or bouncing up and down, you're probably going to see a problem that is sinusoidal. So let's talk about these 2 wonderful people, Dr. Chuckles McLaughlin and Congresswoman Penny Prankster. I think I voted for her. I don't know, she's not doing her job. They're enjoying a ride on a Ferris wheel with a radius of 30 feet. The bottom gondola, which these are called gondolas, the bottom gondola is positioned 3 feet above the ground and rotates clockwise once every 45 seconds. All right, so let's pause right there. You got yourself a circle. You got yourself a radius of 30. You got yourself the fact that this is 3 feet off the ground, which means if I were to label these, which I'm going to do in a moment, you know that you're going to be 3, and you're going to be 30 more than that, and you're going to be 30 more than that. Okay, so that's the information that I have so far when it comes to height. Okay, what else do I know? Well, it rotates clockwise every 45 seconds. So these guys are going to be, perfect line, Mr. Parrish. These lines are going to be 45 seconds apart, or these dots, A and E, are going to be 45 seconds apart. So this is going to go around 45 seconds later. So that's our period right there. So let's erase that ugly looking picture, and let's erase that because I'm not happy with it, and we'll probably draw something similar again. The Ferris wheel starts its rotation cycle when Chuckles and Penny board the indicated gondola. So right there. It also said it went clockwise, which tells us if something is going to start there and go clockwise, start at the middle and go clockwise up and to the right. It's going to be a sign, but we're not there yet. And by it's going to be a sign, it's going to be a sign and not it's going to be a sign. Okay. I saw one of those and it opened up my eyes. It's a base. The height of the Ferris wheel, h, is modeled by the sinusoidal equation h of t after t minutes. Great. The graph of h and its dashed midline for 2 full cycles are shown. 5 points A, B, C, and E are labeled on the graph. No scale is indicated. No axes are presented. Determine the possible coordinates of the 5 points A, B, C, D, and E. All right, so issue number 1. Issue number 1. We start right here, but that's not one of our points. But am I going to let that stop me? No, sir. No, ma'am. So I'm just going to say that if this is the beginning of our ride, we have time 0 at the height of 33. Now, if the period is 45, that means every time I hit a maximum back to midline, minimum, and back to the original is going to be 45 divided by 4. Okay, every middle, top to middle to bottom, every time I hit one of these four things is going to happen at 45 over 4 seconds later, and 45 over 4 is 11 rather 0.25. So why does that matter to me? Well, that means the time for A is going to be 11.25. The time for B is going to be 11.25 more than that, so 22.5. The time for C is going to be 33.75. The time for D is going to be 45, which makes sense. And the time for E is going to be 11 more than that, which is going to be 46.25. 0.25. Okay. Now the heights for these guys are obvious. 63, back down to 33, back down to 3, back up to 33, and back up to 63. So there's technically, since it doesn't tell me how many cycles are done in a cycle or whatever, in a ride, I have an infinite amount of answers. But the obvious ones for me are the ones that start out at A, so 11.25, 63, B, which is 22.5, 33, C, which is 33.75, regular 3, D, which is 45 seconds, 33 at height, and E, which is 50. Oh, close one. That was a close one. 56.25, 63. All right. So like I said, in pretty much every single practice test that I have taken that has free response questions, problem 3 is very, 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 very similar. And we answered these. Whether it gives you some kind of different sinusoidal thing, whatever, that's what we came up with. Now, part B is giving us all the same exact information, but asking us to write out the formula. Now, let's take a look at the information that we have. Whenever you are given a circular thing and you're given a radius, that is your amplitude. Your amplitude is always going to be the radius. So the radius is 30 because it goes 30 up that way, 30 down that way. Okay. Which, by the way, since this happens 3 feet off the ground, 33 is going to be my midline. So let's write that down here conveniently several spaces away. Okay. Now we said that the period is 45. If this is a sine function, I need to find B, which is the frequency. The frequency for a sine or cosine function is 2 pi over the period that you came up with, which is 45, which I can't simplify that, so we'll leave that as 2 pi over 45. Don't know why I rewrote it, but I did. Now, since we started this at sine, since this starts here, right, and goes up and then down and then up and down. Remember, it starts here and then goes up and then down and then up and then down. We start where sine is supposed to start, just shifted up 33. Okay, just shifted up 33. So what is my vertical or horizontal shift? Well, I don't have one. There is no horizontal shift. Now, putting this in order, right, gives me my A, B, C, and D. So my amplitude is going to be 30, which means A is 30. B is my frequency, which is 2 pi over 45, me writing it out the third time. I don't have a horizontal shift, so C is nothing. And my midline is 33, so D equals 33, thus completing part B of our sinusoidal example. Now, this guy is typical of what you can expect to see for these types of problems. If you remember, the picture that we were given had A up here. Let's go back. Let me double check. Yep. Had A up here and then repeating at E. So you had A, you had B, you had C, you had D, and you had E. Drawn perfectly. It's telling me that the t coordinate for B is t sub 1. So this is t sub 1 something, who cares? We actually know what it is, but it's t sub 1. It's telling me that C's x value is t sub 2 something. Okay? Which of the following is true about H? H is positive and increasing. So H stands for height. So first things first, the height of the Ferris wheel is always going to be positive. So you guys are impossible because this says the height's negative. Buddy, you'd be underground, and that's a Ferris wheel I don't want to be on. Now, from B to C, H is positive and increasing, or H is positive and decreasing? In this case, I know it's tempting. But you might be thinking, yes, the t value is moving to the right. That's not what I want. The t value might be increasing, but the height, my dear friends, is decreasing, giving us the answer B. Okay? Now, what 2 is asking is describe how the rate of change h is changing on the interval. Whenever you see the rate of change changing, that's concavity talk. Now, this is the same thing. This is the left side of concave up. The left side of concave up is decreasing at an increasing rate. So the rate of change is decreasing at an increasing rate. And that's how they want you to answer that one. All right, so that's the sinusoidal function. Expect something like that on pretty much all the pre-calculus AP exams that I've looked at. There's a bunch of them, and they're very similar for problem 3. So does that mean it's definitely going to look like that on the test? I don't know, but it's worth a shot. So this is what it's going to look like maybe. Hope this helps. Okay, so if you're looking at problem 4 and you're like, the heck is this? This is problem 4. On the actual AP Precalculus exam, free response question 4 is going to give you like these list of like directions that you need to follow. Otherwise, you're not going to get full credit. Like it'll tell you about like domains and stuff like that. Radians, you already know that. But, you know, the main thing here is if you can simplify something that's simplifiable, do it. Like, for example, if you're looking at like log base 2 of 8, you know you can write this as log base 2 of 2 to the third, which simplifies out to 3 and stuff like that. Okay, so if you can simplify them to whatever you can simplify them to, and you'll be good to go. Okay. Same thing here. If you can combine like terms and make that 5x, if you can combine like terms and make that 5 to the 5th, x to the 3rd, ln of 15 because you multiply the insides, do that. Okay. And so we will have a problem today that it will be a kind of a gross answer that we won't simplify. But again, if it's not a gross answer, try to simplify it because they're going to make you. So here we go. Part 4, question 4, part A gives us f of x and h of x, and they're both gross looking. Actually, f of x is the only one that's gross looking. The function f and h are given by f of x equals tan arc cos, which, by the way, I hate that. I'm going to rewrite it. Inverse cosine, 10 inverse cosine of x. Okay? Sorry, AP. I don't follow your rules. And then there's h of x, a bunch of lots. Solve f of x equals 5 pi for values of x in the domain of f. All right. Okay. So f of x in this case is 5 pi. All right. That's going to equal 10 cos inverse of x. Okay. This is problem numero I. All right. If I want to solve for x, I have to get rid of the inverse cosine, but first I need to divide both sides by 10. 5 pi over 10 is pi over 2, and pi over 2 equals inverse cosine of x. Whoa, 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 buddy, you might be thinking. The heck is all that space for? Well, in order to get rid of inverse cos, I can use regular cos. If the opposite works, then why not? Okay, cos of pi over 2 is what x value is going to happen when I do cosine of pi over 2? Well, 0, of course. So 0 is going to equal x, or x is going to equal 0, which happens to be in my domain. And so I'm in great shape. Problem I solved. Problem double I, which is what I'm called when I'm not wearing my glasses, says h of x equals 3. So 3 double I, 3 equals log, ignore that, log, and you know what? I'm not going to do it. 4 minus x minus log of 1. Fun fact, log of 1 is nothing. Get rid of it. So I have 3 equals log base 10 of 4 minus x. I have to unlock the x. How? Well, you take the base 10 of both sides. And what that does is these guys cross out. You have 10 to the third, which is 1,000, equals 4 minus x. Subtract 4, and let me write it over here. Negative x equals 996. And if negative x equals positive 996, then positive x equals negative 996. That's an extra 9. That's not necessary. Oh boy, I wish they would put that in my paycheck. I'm on fire today. Okay? Part A, uno, dos unos. Nope. Hee. All right. Ugh. Rewrite p of x as a single logarithm base 2 without negative exponents in any part of the expression. All right, well, kind of what you saw in the little directions here, all the logs have the same exact base. Okay, if you add logs of the same base, you multiply the insides. That should be a B to make things easier. Otherwise, it would be a waste. What color am I using? Red. B is going to be log base B of ab. I have 6 of those. And if you subtract logs of the same base, you divide the insides. So it's going to look like this. And if you have a number floating around in front of a log, you can take that number and move it up here and make it an exponent like so. Yeah. So the first thing that I'm going to do is I'm not going to do anything yet, but move that 11 up there. So log base 4 of 2x minus 1 minus log base 4 of 3 plus x to the 11th power plus log base 4 of x to the 7th. These two we're subtracting. So let's do log base 4 of u, 2x minus 1, over u, 3 plus x in parentheses to the 11th. And we're still adding log base 4. Now, when you add two things, you multiply the insides, which is going to put x to the 7th up here in the numerator. So my final answer is going to be log base 4 of x to the 7th, parentheses 2x minus 1, close parentheses, over 3 plus x to the 11th. And I'm not going to simplify that because no one's going to want to simplify that. But that is a single logarithm. Now, what double I is asking for us to do is simplify this guy right here. Whenever you're being asked to simplify, if you see a cosecant, write it like the way it's supposed to be written, 1 over sine x. if you see a squared of a trig thing, try to find its Pythagorean identity. 1 minus cos squared x is the same as sine squared x. So why don't I put that over 1 for funsies? Oh, wait a minute. 2 sine x is on the top and 1 on the bottom? Well, let's cross u out. These 1's are useless, and I'm left with just sine x. So that's how I do that one. Sine x infection. I am on fire today. Ooh. Part C, and the last thing. 3 times 4 to the x in parentheses squared over 2 to the x in parentheses times 2 to the 2x in parentheses. Find x such that r of x is 6. So r of x is 6 is going to equal 3 times. And you know what? I see these bases of 2's. Let's make 4 a base of 2. So that's going to be 2 squared to the x, which is 2 to the 2x, to the second power over 2 to the x, 2 to the 2x. 3 is not going to combine with any of these. 3 is 3. Okay, so 6 is going to equal 3. When I have a parentheses with a power in it taken to another power, we multiply the exponents. So u become 2 to the 4x, 2 to the 4x. When I'm multiplying terms of the same base, I add the exponents. So 1x plus 2x's is 3x's. Ooh, I have 2 to the 4x over 2 to the 3x. When you have terms of the same base and you're dividing the one from the other, you subtract exponents. So 3 has not been bothered with yet. And 4x's minus 3x's is just going to be 2 to the x. Now what I can do is divide both sides by 3. The left side becomes 2, and 2 equals 2 to the x. If only I knew what the exponent was for 2. I do know it's 1. So if you have terms of the same base being equal to each other, set its exponents equal to each other, and 1 will equal x, or x will equal 1 because that's proper. That, ladies and gentlemen, concludes the ultimate GOAT test, ultimate AP Precalculus GOAT Volume 2. It's a lot, but I believe in each and every one of you to do it. So thanks for watching. Hope all of this helps. I love you, and hope this helps. I know I said it twice, but I have to end the video by saying hope this helps. So I hope this helps.